Ganga Gurukulam and Tagore Public Schools. And online, we have sent the letters and intimation to many schools and other fellows and members also. So hopefully they are also to be connected. We welcome our Honorable President, Professor Ajay Bhatak, who was professor, eminent professor in IIT Delhi and very scholarly person known world over for his work on light and several books which Sir has published on light and related subjects, which are read all over the world. Several books are also on the websites, and presently he is the Honorable President of this first Science Academy of this country. So we welcome you, sir, and we are fortunate to have you here as to inaugurate this function. We have other very distinguished guests and the speakers like Professor Satyadev sir, the General Secretary Headquarters, as well as the Chief Editor of the Proceedings of the National Academy of Sciences, Section A, Physical Science, and an eminent mathematician, emeritus scientist and professor in Harishchandra Research Institute of Mathematics and Mathematical Physics. We welcome you, sir. We have other very distinguished speakers and mathematicians like Professor S.S. Khare, former Vice Chancellor of Northeastern Hill University, Shillong, and very known mathematician all over the nation and the world. We have Professor Ramjilal, who was professor in the University of Allahabad and a very close associate of this academy, a very senior professor, and he is known for his excellent teaching modes and his attitude for communicating mathematics among the students, especially the children, in a very interesting manner. We have Professor B. Tripathi, who is also professor in the Allahabad University CMP Degree College, and very uh, interesting person in the respect of he is not only a mathematician, but he is also a very good poet. So being a mathematician and also poet, that is a difficult combination. And his teaching skill is also praised all over. And he is very famous in Allahabad for teaching mathematics in a fun. We have with us Professor U.C. Srivastava, our honorary treasurer and emeritus scientist, as well as the managing editor of the Proceedings of the National Academy of Sciences, Section B, Biological Sciences. And he was earlier professor, emeritus professor in the Department of Zoology, University of Allahabad. We welcome you, sir. So with this small introduction, and we have a few teachers also, like Sanjay ji has come and others have also come, I think. And we have the participants offline and online. We welcome all of you. And now with the permission of the chair, we are going to start the session with the inaugural address by our Honorable President, Professor Ajay Bhatak, sir. Sir, over to you, sir. Sir, unmute. Please unmute yourself. और स्लाइड सर फुल स्क्रीन मोड में अभी भी सर म्यूट है
Can you hear me now?
Yes, sir. Sir, a bit loud. Actually, it is required because the students are here. So,
Can you hear me now?
yes, sir.
Shall I-
Yes, sir. Perfectly,
All right.
all right, sir. Perfectly.
Thank you very much. Dr.
Thank you.
Neeraj Kumar
In
and
large
all
scale.
your colleagues at Nasi, Professor Satyadev, Professor U.C. Srivastava, Professor Khare, Professor Ramji Lal, Professor Tripathi, and all participants, teachers, students. It is indeed a great pleasure. I'm indeed very grateful to Nasi, Dr. Neeraj Kumar and his colleagues for organizing this beautiful event. celebrating the Mathematics Day in our country. I am a physicist, so I will speak on physics, but physics is very intimately related to mathematics. And in fact, I will talk on some of the beautiful experiments in physics. Neeraj, can you see the slides?
Yes, sir.
All right. And my voice is clear. So
Yes.
I welcome all students and all teachers to this very important meeting. Today, as Dr. Neeraj Kumar has just now mentioned, we celebrate the 134th birth anniversary of the great mathematician Srinivasan Ramanujan, who at the age of 13 completely mastered a book on advanced trigonometry written by Professor Loni. By that time, he had also discovered sophisticated theorems on his own. And on 16th January 1913, when he was about 27 years old, Ramanujan wrote his first letter to Professor Hardy, and in which he wrote, I have not trodden through a conventional university course, but I am striking out a path for myself. I have made a special investigation of divergent series, etc. And thus started his long association with Professor Hardy. And Professor Hardy, and that is the greatness. I want to emphasize the tremendous leadership qualities that it was Professor Hardy who organized a visit of Ramanujan to Cambridge and nurtured him to excel in research. In our country today, we require such people of leadership because there are many, numerous. My own experience tells me that there are thousands of young, very bright students in our country who need to be nurtured, who need to be provided the proper environment for research. So there is this beautiful book which I will recommend to all, The Man Who Knew Infinity, A Life of the Genius Ramanujan by Robert Canigal. And it's a beautiful book, and it describes, without going into any equations, the greatness of Ramanujan. And while reviewing this book, Clifford Stoll wrote, and that sums up what Ramanujan was, what Mozart was to music, and what Einstein was to physics, Ramanujan was to mathematics. Now that is really a tremendous compliment, and I don't have to add anything more to the genius of Ramanujan. So this particular talk that I'm going to give is going to be very elementary physics, primarily meant for young students to enthuse them to do new experiments. Professor Robert Crease is a philosopher and historian of science. In 2002, Professor Crease asked physicists to nominate the most beautiful experiment of all times. And from that emerged a list of 10 most beautiful experiments in science. So the experiments that I am going to describe to you today very briefly are not my list. They are the list that has been created by Professor Crease. And of course, many people have commented that there are many more beautiful experiments in physics. But I will just concentrate on those experiments which were put forward by Professor Crease after getting the response of hundreds of physicists. The 10th experiment, 10th uh, most popular experiment is the Foucault's pendulum, which was first demonstrated by Leo Foucault in 1851. And through this pendulum, he demonstrated the rotational motion of the earth. So you see, this is my earth, which is revolving. In about 24 hours, it revolves it makes one complete revolution. So it is rotating about the north-south axis. And since on the equator, for example, the radius, the distance traversed in one day is much more than at a latitude of Paris or Delhi or something like that. So therefore, the velocity, the rotational velocity of the point A will be much more than that of point B. In fact, the point A will have a velocity has a velocity of about half a kilometer per second. But the velocity in a place like London or Delhi will be smaller. So at a latitude of 60 degrees, the velocity is half of this. And so therefore, if I throw a cannonball from the point A towards the point B, let us suppose I throw a cannonball directed at the point B, then the cannonball itself has a lateral velocity of 0.5 kilometer per second. So by the time it reaches the point B, the B would have moved a smaller distance and the cannonball would have been displaced slightly. So although it is pointed north, it will not hit the point B, it will hit a point slightly shifted away from B prime. This is known as the Coriolis effect, and it is due to the rotational motion of the Earth. So in 1851, Foucault suspended a 67-meter long wire, and at the bottom of it, there was a spherical brass-coated lead ball weighing 28 kilograms at the Pantheon, Paris. This is a temple of gods. And he oscillated the pendulum, and the plane of vibration rotated. And that is because of the Coriolis effect that I just now mentioned. And from this rotation of the plane of the vibration, one could determine the velocity of rotation. So there is a very beautiful video in the book. You will have the link, and I wish I could show the video. So this is in the Chicago. There is this beautiful video on YouTube where they show the slight rotation of the plane of oscillation in the clockwise direction. In the southern hemisphere, it will rotate in the anti-clockwise direction. So as the pendulum swings back and forth, it rotates slightly in the clockwise direction. So this is the screenshot at 6 minutes 18 seconds. And as you can see, it is just on the right of this. And in the next oscillation, it flips this bar at 6:35. The previous slide was at 6:18, and the next slide, it flips through. So the plane of vibration rotates. And that is because of the Coriolis effect that I just now mentioned. So therefore, Foucault in his experiment demonstrated that the Earth is rotating, spinning around an axis. I thought I will tell you all that I don't know, there may be other places, but there is a Foucault's pendulum at the Ranchi Science Center in Ranchi. At the latitude of Ranchi, the pendulum's path rotates by about 6 degrees per hour in the clockwise direction. So there is no electricity required, just a long, heavy pendulum. And why do you require a long, heavy pendulum? So that it overcomes the friction of the air. And therefore, to overcome that, you can have an evacuated jar or something like that. So I have been telling Dr. Neeraj that we should have a Foucault's pendulum in Prayagraj and maybe in Nasi headquarters. That would be really lovely. Next experiment is, ninth experiment is, by studying the scattering of alpha particles by thin films of gold, Rutherford discovered the tiny atomic nucleus. You see, each atom, as you all know, consists of a tiny nucleus whose diameter is about 10 to the power of minus 15 meters, 1 femtometer. And Rutherford is considered as the father of nuclear physics, and his colleagues did the experiment in 1911. So what is scattering? So I have an interstellar object coming from a very long distance with a large velocity. As it approaches the sun, it gets attracted by it. And then it moves in a different direction. So this change in direction of the object is called scattering. And so this is the scattering of an object, and this trajectory is a hyperbola. It's a hyperbola. Similarly, if you have a positively charged alpha particle approaching a positively charged nucleus, then it will get repelled. But since it is inverse square law, the trajectory will again be a hyperbola. This change in the direction of movement is known as scattering. So Rutherford derived this formula. S is known as the impact parameter, this distance, which I have defined on the slide. Theta is the angle of scattering. Z1q is the charge of the alpha particle. Z2q is the charge of the gold nucleus. E is the energy of the alpha particle. And epsilon 0 is the dielectric permittivity of the free space, which has a certain value, 8.8574 into 10 to the power of minus 12 in MKS units. So if you substitute this was derived by Rutherford. One can see the handwritten notes of Rutherford on the internet. So alpha particle has charge 2. Q is the electronic charge or the proton charge. And the charge of the nucleus is 79. The charge, the velocity, the energy of the alpha particle is about 5.3 MeV, million electron volts, which is so many joules. A 100-watt bulb gives out 100 joules per second. So that is a unit of energy. And if you substitute these values, you will get S is equal to 2.1 into 10 to the power of minus 13 cot theta by 2. So this formula was derived by Rutherford around the beginning of the 20th century. And this is known as the Rutherford scattering formula. So if you have 179 degrees, that is, it is almost backscattered, then the impact parameter should be so small. And if theta is 170 degrees, it will be about 18.4 femtometers. This is 10 to the power of minus 15 meters. So if J.J. Thomson's model of the atom was in the plum pudding model of the atom put forward by J.J. Thomson around the beginning of the 20th century, the atoms are assumed to be uniform spheres of positively charged matter, in which electrons are embedded like raisins in a cake, like kishmish. Raisin is kishmish in a cake. If this model would be correct, alpha particles should have passed through the foil with very little scattering, if this was large. But he found backscattered alpha particles. This was a very beautiful experiment. And the radius of the gold nucleus, for example, now we know is about 7 femtometers. So this was the experiment that Rutherford did. Actually, it was carried out by his students, Geiger and Marsden. Some of you have heard of this Geiger counter. But the Nobel Prize went to Rutherford. So here is a radioactive polonium source emitting alpha particles, which is the nucleus of the helium atom. Lead bricks, and then it hits a thin gold foil, and he found that they are backscattered, large angle scattering. And this large angle scattering, using his formula that I described, would only be possible if the, the, the nuclear dimension was of the order of 10 to the power of minus 15 meters. So he could establish that the atom consists of a tiny nucleus and is an electron cloud surrounding it. So Rutherford received the 1908 Nobel Prize in Chemistry, and in chemistry, not in physics, although he is the father of nuclear physics. I have dealt with many different transformations with various periods of time, Rutherford said, but the quickest that I have met was my own transformation in one moment from a physicist to a chemist. Then the third from the bottom experiment, Galileo showed that the distance, he put an object on a frictionless plane and measured the time that it takes to traverse this distance. And he found that the distance is proportional to t square. That is proportional to the square of the time. And this was before Newton. Before Newton. So the laws of motion were not known at that time. So the distance traveled is proportional to the square of the time. At that time, there were no watches. How would you measure time? And if you make it fall vertically, the time that it takes is very small, about second or even smaller than second. And there was no device to measure that small time. So how do you measure time? What Galileo did was he took a large bucket of water and a huge bucket, and he allowed the water to fill in and measured the quantity of water, and from that measured, it is like an hourglass. So by measuring the quantity of water that is collected, he related it to the time. So that was the instrument that he used to measure time, and it was all relative measurement. This formula was put forward by Newton, but Newton came after Galileo. Newton was born the year Galileo died. So Robert Crease, who I had shown in the first slide, said that in many respects, it was the first modern scientific experiment in which an investigator systematically planned, staged, and observed a series of actions in order to discover a mathematical law. This mathematical law was S is proportional to T square, is also known as an empirical law. इसको empirical law कहते हैं, which is deduced from a large number of experimental observations. Then the seventh experiment is really beautiful. Eratosthenes, around 3rd century BC, ये अर्थ का diameter कितना है? How big is this earth? Whether it is spherical at all or not, or whether it is flat. He measured that. Beautiful experiment. You know, Tropic of Cancer, ये करीब 23.6 degrees latitude पर है. The earth is spinning around this north-south axis. And on the Tropic of Cancer, parallel rays from the distant ray hitting normally on the Tropic of Cancer on June 21 around noon time. तो 21 जून को 12 बजे के लगभग इस लैटिट्यूड पर rays hit normally. देखिए, the Tropic of Cancer passes through Gujarat, Rajasthan, Madhya Pradesh, Chhattisgarh, Jharkhand, West Bengal, Tripura, and Mizoram. This is the Tropic of Cancer. It has a latitude of 23.6 degrees. तो हर शहर में 12 बजे के आसपास you have rays, sun is right on the top of your head. So there is no shadow. So this is through Madhya Pradesh, Tropic of Cancer. आप लोग जाइएगा, उसको देखिएगा. और वहां पर हर जून के महीने में in the observatory in Ujjain. Ujjain is on the Tropic of Cancer. So vanishing of shadow, ये देखिए, ये vertical pole है, ये shadow नहीं है इसमें. And he's sort of demonstrating it like an eureka moment. The observatory was constructed by Maharaja Jai Singh in 1719. तो 21 जून को उज्जैन में अराउंड 12:30 बजे के करीब vanishing of the total vanishing of this shadow होता है. अच्छा, तो what, and this is another, that when sun rays, you see, ये गाड़ी के नीचे देखिए shadow है, लेकिन यहाँ shadow नहीं है. The sun is right at the top. So what the experiment Eratosthenes did was, और ये कब, 2500 साल पहले, 2500 साल पहले, कि he said that यहां पर अगर शैडो नहीं है और यहां पर अगर शैडो है, तो उसका मतलब है कि अर्थ कर्व्ड है. ये कार्ल सैगन का बहुत सुंदर एक वीडियो है, जिसका मैंने किताब में रेफरेंस दिया है. आप YouTube में जाइए और कार्ल सैगन का वीडियो देखिए, और उसपे उन्होंने बहुत अच्छी तरह से एक्सप्लेन किया है that showing that the shadows will be of unequal length only if the earth is curved. अगर ये फ्लैट अर्थ होता तो दोनों जगह पर शैडो का लेंथ सेम रहता. सो वहां पर एक बहुत डीप एक वेल है, कुआं है. He showed that around noon time on June 21 in a place near Sain, ये करीब अफ्रीका के थोड़े ऊपर है, मेडिटेरेनियन के पास है. The sun is directly above a deep well. And then what he did was, this is Sain, तो यहां तो रेज बिल्कुल नॉर्मली आ रही है, नो शैडो. उसी वक्त एक पॉइंट ए पर ये एंगल जो है, ये शैडो है इस लंबा लंबा पोल का, खंबे का. तो ये शैडो का लेंथ मेजर करके ये एंगल मेजर करते हैं. तो ये एंगल मेजर हो गया, ये 800 किलोमीटर है. तो उससे, तो दिस इज, he made a measurement of the shadow at Syene and at Alexandria, which was about 800 kilometers. He measured the angle to be about 7.2 degrees, and from which he could calculate that the circumference of the earth is should be about 40,000 kilometers. तो ये theta 360 degrees है और 7.2 degrees ये है, simple geometry. So that is, this is 50 and this is 40,000. The circumference of the earth is about 40,000 kilometers, was put forward by Eratosthenes, and this is one of the most, और ये हिंदुस्तान में अगर आप उज्जैन में 12:30 बजे और उसी वक्त किसी एक दूसरे लैटिट्यूड पर आपने अगर शैडो को मेजर किया और उसका डिस्टेंस आपने पता किया, then you can find out what is the circumference of the earth. It's a beautiful experiment. And many students in India, because India is very fortunate to have the Tropic of Cancer passing through 8 states, 8 राज्यों के through जाता है. So Robert Crease writes, the beauty of the experiment lies in the way it makes possible the discovery of a dimension of cosmic proportions. एक बहुत बड़ा dimension, that is the diameter of the earth, by measuring the length of a tiny shadow. एक छोटा सा shadow का length measure करके हम अर्थ का circumference को measure कर सकते हैं using simple geometry. Then the experiment number 6 is Cavendish's torsion bar experiment, which determined the gravitational constant and weighed the world. पृथ्वी का वजन कितना है उसको उसने डिटरमिन किया. And this was in 1798. तो जैसे आप लोगों को मालूम है, अगर दो masses हैं, उसको Newton put forward this law that the force of attraction is proportional to the product of the masses. एक ऑब्जेक्ट दूसरे ऑब्जेक्ट को एक खींचता है. There is a attractive force. This is known as the force of gravitation, which is proportional to the product of the masses and inversely proportional to the square of the distance. And this constant is known as the gravitational constant. To the above law, ये सिर्फ आप लोगों के लिए, if we add the fact that if a force F acts on a body, then its acceleration will be given by force divided by mass. तो ये दोनों अगर हमने बता दिया, then Richard Feynman, in his very beautiful lecture, which is also on YouTube, I have said everything about the law of gravitation. तो अगर inverse square law and the fact that the acceleration is equal to the force divided by the mass, then I have told you everything about the law of gravitation. Of course, there were small changes, well, no, very big changes made by Einstein, but that is general theory of relativity. But law of gravitation are just these two equations. So what Cavendish did was a very beautiful experiment, और ये आप YouTube पर देख सकते हैं, बहुत सुंदर experiment है, that you have a large ball and a small ball. तो लार्ज बॉल को जब स्मॉल बॉल के पास लाते हैं तो वो ट्विस्ट कर जाता है. इट इज अट्रैक्टेड टुवर्ड्स द स्मॉल बॉल, और उस ट्विस्ट को मेजर करके यू कैन फाइंड आउट द ग्रेविटेशनल कांस्टेंट एंड देयरफॉर द मास ऑफ द अर्थ. बहुत सुंदर एक्सपेरिमेंट है. एंड सो दिस इज वन ऑफ द मोस्ट ब्यूटीफुल एक्सपेरिमेंट. ये जो what I would like to tell the younger generation is that you people are very lucky. We are all very fortunate to have internet everywhere. इंटरनेट की वजह से you can see everything. आज मैं दिल्ली में बैठा हूं, आप लोग प्रयागराज में हैं और आप हमें सुन पा रहे हैं. Is it because of the internet? आप एक न्यूयॉर्क में या लंदन में लेक्चर को सुन पाते हैं because of internet. और YouTube तो एक बहुत बड़ी दान है. And you see experiments, you see lectures, you hear Feynman lectures of Nobel laureates, and you can learn so much. If you want to learn mathematics, quantum mechanics, field theory, सब कुछ internet में है. चलिए. So according to Professor Crees, Cavendish managed to carry out an extraordinary experiment whose precision could not be significantly bettered for a century. तो मैं इनवर्स स्क्वायर लॉ के बारे में थोड़ा सा 2 स्लाइड बताना चाहता हूं. तो गैलीलियो ने कहा था कि on the surface of the earth in 1 second a ball should fall through a by distance of 5 meters. ये याद रखिएगा. अगर हम एक ऊंची बिल्डिंग से एक बॉल को गिराते हैं, so the initial velocity is 0, so it acceleration due to gravity is about 10 meter per second. और अगर 1 सेकंड में t is equal to 1 second, so half into 10 into 1, that is about 5 meters. So on the surface of the earth, अगर आप एक बॉल को गिराते हैं तो 1 सेकंड में करीब 5 मीटर जाता है. Now look, how did Newton arrive at the new inverse square law? तो उसके पास, न्यूटन के पास observational data of Tycho Brahe was there and Kepler's laws was there. तो मून एक चक्कर लगाता है सराउंडिंग द अर्थ इन अबाउट 27.3 days. तो उससे ये डिस्टेंस जो है इट इज अबाउट 400,000 किलोमीटर्स. तो जो मून का रोटेशनल वेलोसिटी सराउंडिंग द अर्थ है वो करीब अबाउट 1 किलोमीटर पर सेकेंड है. तो चंद्रमा जो है approximately in a circular orbit moves around the earth, rotates around the earth with a velocity of about 1 kilometer per second. तो 1 सेकेंड में यहां पर 1 किलोमीटर गया. अच्छा, नाउ लेकिन अगर मान लो कि ये अट्रैक्टिव फोर्स नहीं होता, तो ये जो मूव कर रही है, ये ए पोजीशन से सीधा जाता, बिकॉज इफ देयर इज नो फोर्स एक्टिंग इट वुड ट्रैवल इन अ स्ट्रेट लाइन। तो ये डिस्टेंस 1 किलोमीटर है। तो बिकॉज द फोर्स it moves through a distance this, because of the attractive force of the earth, the moon goes from the point B to the point D, because actually moon तो circular orbit में जा रहा है। अगर gravitational pull नहीं रहता तो ये यहां पर पहुंचती। so this distance simple geometry से आप कैलकुलेट कर सकते हैं, it is only 0.14 सेंटीमीटर। ये जो डिस्टेंस है, तो मून अगर सीधी जाती, अगर कोई फोर्स नहीं होता, और ये जहां पर ये सर्कुलर ऑर्बिट में है, ये डिस्टेंस जो है इट इज अबाउट ओनली 0.14 सेंटीमीटर। तो रेडियस ऑफ द अर्थ is a radius of the orbit is about 400,000 kilometers, which is about 60 times the radius of the earth. तो इनवर्स स्क्वायर लॉ अगर वैलिड है ऑन द, सो देयरफॉर यहां पर जो फोर्स होगा वो 3600 गुना ज्यादा होगा, because the distance is 60. Inverse square law में the force will be 13600 at this point. So therefore, if ध्यान से सुनिए, if the inverse square law is valid, then on the surface of the earth in 1 second it should fall through by 0.14 into 60 into 60, which is about 5 meters. And this is what Galileo's measurement has given. So that from this calculation, a similar type of a calculation, Newton unified. Newton का main contribution क्या था? Unified the gravitational force on the falling apple with the force responsible for planetary motion. जो force एक apple को पृथ्वी की ओर खींचती है, वही gravitational force एक चंद्रमा को पृथ्वी के चारों तरफ घुमाती है। This according to Feynman. Feynman ने एक बहुत सुंदर ग्रेविटेशनल पर लेक्चर दिया था, तो आप YouTube में जाइए and write Feynman's lecture on gravitation. You will get a very beautiful video. So this, according to Feynman, is the greatest generalization achieved by the human mind. Greatest generalization achieved by the human mind. Feynman said this in his messenger lecture on gravitation at Cornell University, and which is now available on YouTube. You know, I did my PhD at Cornell University, and I came back to India in 1964, and I never could attend Feynman's famous 6 lectures that he gave. But today, because of YouTube, I can hear them. And that was my greatest regret, that I could not hear Feynman. लेकिन YouTube की वजह से हम उसको एक दफे नहीं 10 दफे देख सकते हैं। And indeed, I have seen his 2 lectures, one on quantum theory and the other on gravitation. 10 दफे देखा है मैंने। बहुत सुंदर लेक्चर्स है। आप लोग देखिएगा, आपके पास अगर इंटरनेट हो तो you can study and understand everything. So, but in the same messenger lecture on gravitation, Feynman also said the law of gravitation is also used to calculate the prediction of planets' positions, which have great utility for astrologists to publish their predictions and horoscopes in magazines. And then Feynman says, that is the strange world we live in, that all the advances in understanding use only to continue the nonsense which has existed for 2000 years. चलिए ये तो पौना 12 करीब बज रहा है, तो I'll quickly go through the other experiment. So Thomas Young's, the 5th experiment is Thomas Young's interference experiment. demonstrating that light was a wave. He used two pinholes and he observed the interference pattern. Uske pehle, people believed in Newton's particle model of light. It was this beautiful experiment done, and he just used sunlight passed through a filter, a colored glass plate, then two tiny holes, and he observed black and white interference pattern. And he could say that agar light was in the form of particles, it will either pass through hole number 1 or hole number 2, and the intensities will add up. But if it was a wave, then you will have an interference pattern. So light plus light produced darkness. Therefore, it established that light was indeed a wave and not particles. In fact, people say that, that there is a book, The Last Man Who Knew Everything. That was Thomas Young, the anonymous polymath who was a mathematician, who was a medical doctor, and also a physicist. So the last man who knew everything was Thomas Young. ये तो बहुत सिंपल सा एक्सपेरिमेंट है. न्यूटन 1666 में यूके में प्लेग हुआ था. तो न्यूटन was sent back from Cambridge to his mother's home. He was 23 years old. He did many things. The year 66, 67 was Isaac Newton's Annus Mirabilis, year of miracles. He was then just 23. And he came back to his mother's home and did many things. And then he did this famous prism experiment. And he saw white light split into different beautiful colors. Before Isaac Newton, people thought that white light was the purest. Even today, many write that there are 7 pure colors: violet, indigo, blue, green, yellow, orange, and red. That is incorrect. What Newton demonstrated was that all colors, all wavelengths are pure and fundamental. Then इसको skip कर देते हैं. He determined the electric charge. Millikan, beautiful experiment. And then Galileo का बहुत सुंदर experiment है. This is the second experiment. If two objects of much different weights are dropped from a height, both take the same amount of time. And this was done once again before Newton. And what he said was, Aristotle said that अगर भारी ऑब्जेक्ट को ड्रॉप करोगे तो वो जल्दी गिरेगा. Galileo ने Newton's laws of motion were still not discovered. Galileo predicted both objects will take the same amount of time. And because both have the same acceleration. And there is a very beautiful experiment. आप इंटरनेट में जाएंगे, यहाँ पर a very nice video by Dr. Brian Cox showing that a heavy object, एक बहुत heavy object और एक feather will take the same amount of time in free space. इसको evacuated chamber में हवा निकाल लीजिए तो दोनों एक ही स्पीड से उतरेंगे. ये बहुत सुंदर एक्सपेरिमेंट है और आप लोग YouTube में देख सकते हैं और शायद इसको किया भी जा सकता है बहुत. तो डेविड स्कॉट ने चंद्रमा पर जा करके, एस्ट्रोनॉट है, उन्होंने एक हैमर फेंका और एक फेदर फेंका. तो दोनों, moon does not have an atmosphere, so there is no friction of air, and so therefore both hammer and the feather both took the same amount of time. So that is the most second beautiful experiment. And the top experiment is, I'm almost near the end, double slit interference experiment with single electrons, which demonstrated quantum interference of single electrons, 20th century. तो जैसे मैंने आपको कहा, if light is a wave, then it will undergo diffraction. आप लोगों ने पढ़ा होगा. लेकिन if you take an electron which has a very definite mass, which has a very definite charge, then that also will undergo diffraction. And that can be explained by quantum theory. And one one solves what is known as the Schrödinger equation, one gets that if a electron beam passes through a small slit of width b, the slit imparts the momentum, and the probability of the momentum lying between px and px plus dpx is sine square beta by beta square, which is the same as the intensity distribution obtained using classical wave theory. So quantum theory is probabilistic in nature. Classical physics is deterministic in nature. And from this follows the uncertainty principle. Smaller the width, greater will be the diffraction. चलिए इसके लिए थोड़ा ज्यादा टाइम लगेगा. And so you do the same experiment. अगर particles क्या, जैसे मैंने आपको पहले कहा था, they will either pass through hole number 1 or hole number 2. अगर hole number 1 खुला हो तो it will be intensity distribution like this, it will add up. अगर wave हो तो interference होगा. लेकिन अगर an electron beam pass through a two slit arrangement, then you feel that the electron will either pass through hole number 1 or through hole number 2. But it shows the interference pattern. And so therefore, the electron passes, one electron passes through both the holes simultaneously. This is the classical expression for the intensity distribution. And if you do the quantum mechanics, you get the same expression for the probability distribution. चलिए. So if you do the experiment, since electron has a very well defined mass, उसका mass हमको मालूम है 9.81034 something like that to 10 decimal places. तो आपके दिमाग में वो एक tiny particle है, तो वो या तो होल नंबर 1 के थ्रू जाएगा या होल नंबर 2 के थ्रू जाएगा. तो अगर दोनों होल खुले हो तो you should expect this intensity distribution. It will either pass through hole number 1 or hole number 2. But when you do this beautiful experiment, you observe an interference pattern. And that can be explained only if electron is described by a wave function, which is passing through hole number 1 and hole number 2. It interferes with itself. It's a probability distribution given by this curve. And this experiment is the most beautiful experiment in physics. So you have 10 electrons, you have 10 spots, 100 electrons, 1,000, 3,000, 20,000. And when you have a large number of electrons, then slowly the interference pattern builds up. The two-slit interference experiment of electrons, or for photons, or for protons, or for alpha particles, is a phenomenon which is impossible, absolutely impossible to explain in any classical way, and which has in it the heart of quantum theory. I will end with this beautiful experiment that you have a single photon source, light source. एक photon आ रहा है. एक partially silvered mirror है. Photon यहाँ भी जा सकता है, यहाँ भी जा सकता है. There is a 50% chance of reflecting, 50%. तो आप क्या कहेंगे कि अगर 1000 photons यहाँ आएंगे तो 500 रिफ्लेक्ट होंगे, 500 ट्रांसमिट होंगे? वो गलत आंसर हो. A single photon is transmitted and reflected. So it is here as well as here. And it can interfere with itself to produce the interference pattern. But when you make a measurement, अगर यहाँ पर कोई detector लगा दिया, it will be either here or there. I'll repeat. A single photon, when it hits a partially silvered glass plate, it is in the transmitted beam, a reflected beam, as well as in the transmitted beam. ये यहाँ भी है, वो यहाँ भी है. It can interfere with itself to produce an interference pattern. लेकिन अगर हम इसको measure करते हैं, So the photon or the electron being at both places collapses to being either here or there. तो यही जो experiment है, the electron passes through both the holes simultaneously, and this no one understands. And therefore, Feynman said in his messenger lecture that no one understands quantum mechanics. How does the electron passes through both the holes simultaneously? That no one understands. But quantum mechanics allows us to calculate the probability distribution, which is the same as the intensity distribution. So if you have a particle facing a potential barrier, it is reflected and transmitted. तो ये दोनों distance हजारों किलोमीटर पर हो सकता है. So the particle is described by this wave packet. It is here as well as there. If you make a measurement, then it is either here or there. Chalo. So this is the photograph showing the quality of a picture of a young girl. From 3,000 photons, you get 3,000 spots, and 28 million photons. The quantum theory predicts the probability distribution. But when you detect, it is either one photon or one electron or no photon. So this is seeing the two-slit experiment done is like watching a total solar eclipse for the first time. A primitive thrill passes through you and the little hairs on your arms stand up. It is actually arresting in the way a masterpiece of art or sculpture is arresting. So I have tried to describe the 10 most beautiful experiments in science. That brings to the question, what is the definition of the term beautiful? According to John Ruskin, any material object which can give us pleasure in the simple contemplation of its outward qualities without, इसको ध्यान से पढ़िएगा, without any direct and definite exertion of the intellect, I call in some way or in some degree beautiful. In that sense, I think each experiment was truly beautiful. This is the reference of Robert Crease, the prism and the pendulum, the 10 most beautiful experiment in science. Robert Crease का, and then I have also described, this book gives a history कि उस वक्त इराटोसथेनस के समय में क्या था, गैलीलियो के समय में क्या था, न्यूटन के समय में किस तरह का साइंस. इट्स अ वेरी ब्यूटीफुल बुक जो मैंने अपनी किताब में दिया है. ये जो बेसिक फिजिक्स ऑफ ईच एक्सपेरिमेंट ये मैंने दिया है. And this has come out as a part of our NASI activities. Thank you for your attention. Chen.
Thank you, sir. Thank you, sir, very much. Actually, your experiments, the glimpse of all those experiments, which are really beautiful in the sense that they give the sense of accomplishment done by our great scientists of past era. That is the quality of science as well as the quality of human beings to conceive that in such a manner that it could be productive as well as it could be aesthetic. And in all fashion, it is perceived with total emotion. It creates beautiful science and beautiful experience. Thank you, sir. Your book has already been distributed. You can see the hall is full with all the students. Around 50 students are here, and it has been distributed. And very, we are very much grateful that you spared time.
It is my pleasure.
All the experiments and Fediman, Cavendish, Newtons, and everybody has been defined, well defined. I would like to say, सेव का गिरना चमत्कार नहीं था. सेव का गिरना चमत्कार नहीं था, पर उसमें न्यूटन की सोच की ऊंचाई का कोई जवाब नहीं था.
अरे वाह.
तो विज्ञान तो अद्भुत है और अद्भुत विज्ञान करता है समस्याओं का समाधान. बस जिजीविषा होनी चाहिए जो दूर कर दे हमारी सभी समस्याओं का समाधान.
Thank you.
Thank you, sir. Thank you very much. And now we are coming to the next part. That is the keynote address. Today is the mathematics day. So with the Amrut, actually this Amrut ka Azadi ka Amrut Mahotsav, this program is being led by our honorary president himself. So this was really a part of the Azadi Ka Amrit Mahotsav celebration. And now we are coming to the mathematical uh, science part, and that is the National Mathematics Day. The theme was mathematical societies in India and mathematics for school children. So this was really great. And excuse me. Sorry. So the inaugural address is by, the keynote address is by Professor Satyadev sir. I've already introduced him. He is an eminent mathematician and he has himself experience of roaming around the world and delivering lectures in many corners of the world. And
धीरज,
his,
आप जरा माइक के सामने बोलिए, वो सुनाई नहीं दे रहा है ठीक से.
okay, sir. Actually, can you hear me, sir? Can you hear me, sir?
नहीं नहीं नहीं.
इसमें आवाज नहीं आ रही क्लियर.
देखिए, अब सत्यदेव जी बोले तो उसको.
हाँ.
Yes.
हाँ, now I can hear.
Can you hear me, sir? Hello? Dr. Sir, can you hear me?
Yes, I can. Yes, I can.
So, Professor Satyadev sir is going to focus his lecture on Indian Math Society. Actually,
अब आपका clear है. हाँ.
the Indian Math Society is itself a group of very eminent mathematicians. And how it was founded, what is the rationale behind that, and what is its contribution in the propagation of mathematics and solving the mathematical problems and giving solution to the day-to-day mathematics as well as the science. So I would like to request Professor Satyadev sir to please deliver the keynote address of Indian Math Society.
Thank you, Neeraj.
Thank you very much. Am I audible to?
Yes, you
Am
are.
I audible to everybody? That's all.
हाँ, बिल्कुल.
Acha, very good. Thank you very much. So first of all, I would like to thank the President of National Academy of Sciences, Professor Ghatak, for the beautiful lecture that he delivered. It was really a very beautiful lecture. And I think we all have enjoyed the 10 most beautiful experiments in science. And now I come to the main theme of this day, of today, namely, we are going to talk about the mathematical societies of India and also some school mathematics. Because the children who have gathered here, they belong to plus two, plus one, right? You are from plus two. So it is very important that we should also talk something about the school mathematics. So that is how we have decided to take the theme of today. And today is the birthday of Srinivas Ramanujan, the great legendary Indian mathematician of 20th century. And we are really very proud that he represented India in the whole world of mathematics by doing the most important kind of number theory. And the government of India announced in the year 2012 that we should celebrate the birthday of Srinivas Ramanujan as the National Mathematics Day. And since then, we have been celebrating this. In our National Academy of Sciences, every year we have been celebrating the National Mathematics Day by taking different themes, different topics of mathematics. And today we have four people here, myself and Professor S.S. Khare and Professor Ramjilal and Professor B. Tripathi. We have always been participating in celebrating the National Mathematics Day. And today, again, we will do that. And of course, earlier it used to be a physical meeting, but today it is partially physical and partially online. But I think that we'll be able to do justice to the theme that we have decided. So I now begin the main theme of the today's talks. we have chosen the mathematical societies of India. I don't know these students, you may not be familiar, but I must say the following. You study whatever is known up to +2, and then you go to SC class, where you study mathematics and also other branches of science. And then you go to the MSc, where you study some very advanced topics of mathematics. But at the same time, after MSc, you go towards research. That means you want to then, after that, you start discovering new things about mathematics. Actually, there are a large number of problems in mathematics which are unsolved. And if you solve an open problem of mathematics, you become a mathematician. And it is very important that mathematics should be enlarged. Whatever we know today, tomorrow we will be knowing much more. Very new facts, new theorems, and new ideas enter into the subject. And the same thing happens in every branch of science. And that is where the research actually comes in. And the research actually comes in. Now, for example, if you take Ramanujan, when he passed his high school in having distinction in all the subjects, and he got a scholarship. And then he moved on to do his intermediate, the plus two that he's saying here. And that time it was called FA. So he joined FA school, but he was so much interested in mathematics that he ignored other subjects that were really prescribed in FA class, in intermediate class. And as a result, he failed. And when he failed, he lost his scholarship. He failed because his 100% concentration was only in mathematics. And he was really discovering new theorems, new results. And 100% involvement was only in mathematics. So, but whatever he was doing, he was writing in the form of notes. But you'll be surprised to know that there was nobody who could appreciate whatever he was doing at that time. Most of his results are in number theory, and all of you know number theory. But the new ideas and new results, new terms were being discovered by him. So he started writing all those things in the form of notes. And they were all research material. Therefore, the teachers where he was studying, they could not appreciate. In fact, nobody could appreciate what he was doing. And it was actually a society, only a society, which was named as the Indian Mathematical Society, that it was founded by a person whose name is V. Ramaswamy Iyer. And I am going to tell you the detail of this society. It is V. Ramaswamy Iyer who actually Ramanujan went and saw him.
बाकी सब माइक्स
When
को
he
थोड़ा
saw the
फीडबैक आ
result
रहा
that he
है
was proving,
तो
then he
बाकी
could
सब
realize
माइक्स
the
को ऑफ
talent
कर दीजिए
of this person, this boy
और
was only
उनसे कहिए
of
थोड़ा
your age,
माइक के सामने
and he
बोले
could see that he is a gifted mathematician.
उनका कभी तो ठीक
So
आता
then
है
he
कभी नहीं
advised him.
ठीक आता है मैं
By that time, the
नीरज
Indian Mathematical Society was already there, and he was the General Secretary of Indian Mathematical Society. And at that time, actually, there was no journal. So there were only, he was publishing something called the progress reports of the Indian Mathematical Society. And in that progress report, there were some well-known questions in mathematics, and people came to know about those questions. So if somebody could solve those questions, then they would be published in those progress report, and these progress reports were being published. So he advised him to look at the questions which were being published in the progress report, and Ramanujan saw many questions there, and he solved it, and they were published in the progress report. And that's why many people came to know that here is a genius. And then, of course, Ramaswamy Iyer asked him to if you have any research paper, that also you can publish in these. By that time, the progress reports actually they had become what is known as the Journal of Indian Mathematical Society. So what I'm telling you is that these journals are the Indian Mathematical Societies. There is one Indian Mathematical Society, but there are other mathematical societies also. The whole objective of these societies is to recognize the talent that you have, whether you are at a school level or you are at the graduate level or the postgraduate level. But mostly, if you are at a research level and if you are doing some wonderful work, that means you are creating ideas. If you are creating methods of mathematics, if you are solving open problems of mathematics, then how to communicate your solution to the general public. And this is where the societies play a very important role. So I have requested my colleagues, for example, I am going to talk about the Indian Mathematical Society. And then Indian Mathematical Society is the oldest mathematical society, actually oldest society even in all branches of science. Then there is another very important society which was started after Indian Mathematical Society, and it is known as the Calcutta Mathematical Society. And I have requested Professor Khare to speak about the Calcutta Mathematical Society. And then very recently, the last several years, we started a new society after Srinivas Ramanujan. Because when actually many things were being celebrated, his 100 years was celebrated, then 125 years was celebrated. Many things were known about Ramanujan. So some people in South, they got together, they said that we should have a society called Ramanujan Mathematical Society. And I have requested Professor Ramji Lal, who will speak about the Ramanujan Mathematical Society. These are the three most important societies of our country. And they are something like the American Mathematical Society or London Mathematical Society or the European Mathematical Society. There are other mathematical societies also. For example, there is something called Bharat Ganit Parishad, which is actually a mathematical society which is run by the Department of Mathematics, Lucknow University. You have Aligarh Mathematical Society. And there are several other mathematical societies also. But these three important societies are very important and they are really doing very good work. So we thought that even at this stage, you should know about those mathematical societies. And then I requested that we will be dealing with these mathematical societies and plus also some school mathematics, something that you are reading, so that we can also tell you some delicate points which you must know and enjoy mix that way. So now let me begin. Page. Hmm. Yes. So you read this, by the way, all of you can see that. Read it. Okay. So the beginning of Indian Mathematical Society, actually, it was started in the year 1907. And it was known at that time as a analytical club. And as I said, it was started by a person whose name was V. Ramaswamy Iyer, and he was not a mathematician. He was a deputy collector. You have district magistrates nowadays. You have several SDMs. So he was like one of the SDMs at that time. And remember, we were actually not independent at that time. It was British Raj. So we were under the UK. And so he was only a deputy collector in the Madras residency. And he took several friends of his who were interested in mathematics, and about 20 of them he collected, and then he started a society, and the name of the society was Analytical Club. And what they used to do, that they used to consult the journals which were published in England and somewhere even other places, and they used to see the problems which were mentioned in those journals, and they will solve those problems and will publish. So that is what this analytical club used to do. This is how this society was started. And the club started publishing progress reports, as I told you earlier, solving some problems of mathematics, which were taken from various journals and various mathematicians who will tell that this is an open problem. And this actually worked for 2 years, from 1907 up to 1909. And by that time, many people became interested in solving mathematical problems. And then this club was, a constitution was made. It was named as the Indian Mathematical Society in the year 1909. So the club was renamed as Indian Mathematical Society. So the society was started actually in 1909 with a different name, but finally in 1909 it acquired its present name. And these names are important because they are important. We like these names and we remember them very frequently. So that's why I'm mentioning here that there was again a person who was in civil services, not a mathematician. His name was B. Hanmanta Rao. He was the first president of Indian Mathematical Society, and he was president for 6 years. And V. Ramaswamy Iyer was the general secretary of the Indian Mathematical Society for 4 years. And the IMS is the oldest scientific society of India. And you'll be surprised to know that at present, at that time, it started with only 20 members. And at the present time, we have 2,300 life members and maybe more than this. So the society has been increasing, the membership of the society has been increasing day by day. And also, there was no headquarters so far. I must tell you that if you know about the American Mathematical Society, they have a headquarters in the northern part of America. It's called Rhode Island. And most of the works of the society are done by that headquarters. In India, we have many societies, but no society has a headquarters. Calcutta Mathematical Society has a headquarters in Calcutta because Calcutta was, as you know, it was the center of academic activity. All science and mathematics, they actually emerged from that place. Most of the work was done only in Calcutta. And the person who is very much known and very much respected was Sir Ashutosh Mukherjee, who was the Vice Chancellor of Calcutta University. And it was he who brought all the top class scientists of India to Calcutta University. And therefore, most of the works like Raman worked there. And yeah, our Meghnad Saha, the founder of this National Academy of Sciences, he also went there. In fact, all the top class scientists were encouraged by Sir Ashutosh Mukherjee. So he started Calcutta Mathematical Society in the year 1909. So I was going to say that no society had headquarters except Calcutta Mathematical Society. Indian Mathematical Society is the oldest mathematical society, but it did not have a headquarters so far. But recently we have, because now we are members, we are officials. For example, I am the General Secretary of Indian Mathematical Society. We have been trying to have a headquarter of Indian Mathematical Society, and the first conference was held in Pune. It was actually started in Pune, the city of, you know, it's a great city so far as academic things are concerned. So we are going to have a headquarter there in Pune. The land has been bought, and we are going to now build the campus or the headquarter of the Indian Mathematical Society. Very soon we'll have that. The IMS started publishing a journal called Journal of Indian Mathematical Society from the year 1909, and it is continuing even today. Under the editorship of Professor R. Vaidyanath Swami for 23 long years, the Journal of Indian Mathematical Society flourished, and a new series of the journal was started in year 1934. You may not be knowing that Ramanujan, he was trained, of course, in England by Hardy. Even Professor Ghatak, when he started by giving the photo of Hardy, who was the man responsible to put the genius, Indian genius, before the whole world. So uh, this journal was started by R. Vaidyanath Swami. Vaidyanath Swami was also a great mathematician. Actually, he was a topologist. You may not be knowing what the subject topology is. It's a kind of rubber sheet geometry. You will study it when you go to the MSc level or even BSc level. So he was a very good topologist. So he was the editor of this Journal of Indian Mathematical Society for long time, about 23 years. And during his time, the journal became an international journal, and many good papers were published. At the same time, another periodical, it is called Mathematics Student. See, the Indian Mathematical Society publishes two periodicals. If you go to the library of Nasi or even library of any university or even to our research institute, you find that there are large number of journals being published by American Mathematical Society, European Mathematical Society, and all countries have their mathematical societies nowadays. So they publish journals. So the Indian Mathematical Society publishes two journals. One is the GIMS, Journal of Indian Mathematical Society, and the other is Mathematics Student. Mathematics Student was started after a long time, and it was started in the year 1933 under the editorship of a very good mathematician. His name was Singha Rao, and he was the editor of Mathematics Student for long 21 years. And it became a very popular journal, and even now it's a very popular journal because very good popular articles are published there. Besides research papers, you have published, you see there are very good publications of popular articles, and even there is a problem section. And even if some problems are solved nowadays, you communicate it, and if it is really of a very good interest, then it's published in Mathematics Student. The name shows that it is meant for the students, but actually it publishes research level things. It is quite popular. And these were started long back, and they are still popular. And it is Indian Mathematical Society which is doing. Okay, now I want to say something about Srinivas Ramanujan. This was the time, actually in 1909. You see, remember these years. 1909, JIMS it took its name. Of course, the Indian Mathematical Society was already there. Then from 1909, 1910, 1911, 1912, these were the years when Ramanujan was struggling. Struggling means he failed, he lost his scholarship, and he was only concentrating on mathematics. And he was writing all his results in the form of notes. So this was the time when Ramanujan was struggling with his failure to retain his scholarship and got admission in FA standard. However, he was busy writing his notebooks. He knew that he was discovering some new results in mathematics, but no one was taking interest in the results that he was getting. He met Ramaswamy Iyer and showed his results to him, who recognized his talents and asked him to solve some questions which were being published by the Journal of Indian Mathematical Society. He did that and was noticed by some people as a gifted mathematician. In fact, Ramanujan published his first research paper entitled, this is historical. The first research paper of Ramanujan was published in the Journal of Indian Mathematical Society, and the title of that paper was Some Properties of Bernoulli Numbers in the Journal of Indian Mathematical Society. Society has attracted a good number of people after that. Later on, when he became known to the whole world, in connection, because he went to England and to Cambridge University. Hardy invited him, and then of course, because Hardy recognized that he was really a genius, he encouraged him, he trained him how to write a research paper. Because you may be knowing that he used, for example, if you take an infinite series, and if it is convergent, then it will converge to a number. He was such a genius that without doing anything, he will tell that this will converge to this number. Limit of this series will be this. He was so genius. More than 100 series, he will tell the limit or the number to which that series converges. If you ask him, how did you get it? That because he had such a strong intuition that it was difficult for him to explain how he got it. But he got it because of his intuition. Hardy told him that you have to give a proof of all these results. Only then the people will recognize. And then your results can be published in a research paper. He trained him that way. Then he started proving the results. Otherwise, he had no idea. He had idea of proof, but he never took interest in proofs. You ask a question, he will give an answer. That was because that is the way he was trained actually. The book was projected by our Professor Ghatak, a book which deals really with the whole life of Ramanujan and all aspects of Ramanujan, how he struggled and what he did in the beginning, how he was noticed, then how his work reached England, particularly to Professor Hardy, how he invited him. Everything about the life of Ramanujan had been dealt with in that book, and the title of that book is The Man Who Knew Infinity. And it is written by The Man Who Knew Infinity is written by Bob Canigal. He really wrote this book, and it turned out to be a wonderful book. It has been published, and the Indian mathematicians, particularly the leading mathematicians, they in fact honored him. They invited him to come to India, and they honored him for writing such a nice book. So anytime, whenever you feel like knowing anything about Ramanujan, you pick up that book. It's a very cheap book. You can always find in library, and you pick up that book, and then you can really see what a great genius Ramanujan was and how he struggled. ऐसा कहा जाता है, हाँ यहाँ भी है, सब जगह है. ऐसा कहा जाता है कि जब स्कॉलरशिप उनकी खत्म हो गई तो ट्यूशन चाहते थे और उनको ट्यूशन मिलना मुश्किल होता था. आप सोचिए, इतना बड़ा मैथमेटिशियन वो ट्यूशन पढ़ाना चाहता है क्योंकि कुछ पैसे भी चाहिए थे, शादी भी हो चुकी थी, लेकिन उनको ट्यूशन नहीं मिलता था. और ये भी उसमें आप देखिएगा किस तरह की चीजें डिस्क्राइब की है। कागज पेंसिल भी नहीं था, केवल स्लेट पर लिखा करते थे और चाक लेते थे और ऐसे ऐसे मिटाया करते थे उसको। मैंने ऑल दीज poverty stricken incidents are related there. If you read that book, you will really get thrilled that here was such a genius, but he suffered in such a manner. Anyway, what I'm saying is that the Indian Mathematical Society really encouraged Srinivas Ramanujan, and even when he was known to the whole world and was doing top-class things, he published his research paper in the Journal of Indian Mathematical Society. And a total of 12 research papers of Ramanujan are published in the Journal of Indian Mathematical Society. Many other famous mathematicians have also published. For example, there is a very good mathematician called Selberg. Selberg, he published his famous paper on the trace formula in our GIMS. And even Marshall Stone has published many papers, and very important results have been published there. There is another Indian mathematician. आप लोग जानेंगे नहीं, लेकिन कुछ देर के बाद जब अगर आपका मैथमेटिक्स में इंटरेस्ट हुआ तो आप जानेंगे कि रामानुजन के बाद या उसी टाइम पर और भी लोग हुए हैं जो बड़े अच्छे मैथमेटिशियन थे। संभव उनका वर्क जो रिकॉग्नाइज नहीं हुआ, एंड वन ऑफ देम वाज एस पिल्लाई, and the of course other was Baidyanath Swami, I told you. So S.S. Pillai also solved one of the most important problem of that time, warring problem. अब ये क्या है इसका डिटेल तो हम नहीं बता पाएंगे, लेकिन he solved an open problem which attracted the attention of the whole world, and he was invited to USA. लेकिन वो जा ही रहे थे, उनका प्लेन क्रैश हो गया. तो he also published many papers in the Journal of Indian Mathematical Society. Okay, now I want to tell you what is the function of these societies. ये societies क्या करती हैं? ये सबसे पहला काम तो ये करती हैं कि जितने मैथमेटिशियंस हैं उन सब की साल में एक बार या दो बार एक कॉन्फ्रेंस करते हैं. कॉन्फ्रेंस का मतलब ये हुआ कि जितने मैथमेटिशियंस हैं वो अपना रिसर्च पेपर ले आकर के वहाँ प्रेजेंट करें, और जो अच्छे अच्छे मैथमेटिशियंस हैं जिन्होंने बढ़िया प्रॉब्लम हल की है या बढ़िया काम किया है उनको इनवाइट करके उनका लेक्चर कराया जाता है ताकि सारे मैथमेटिशियंस सुने और इनकरेज्ड हों. और एक छोटे मोटे जो मैथमेटिशियंस हैं या वैसे भी एक दूसरे से बात करें, इंटरेक्शन हो, तो इससे क्या है कि मैथमेटिक्स जो है वो उसकी और प्रोग्रेस होगी और बढ़ेगा. और दूसरी बात ये है कि जैसे आप रिसर्च कर रहे हैं, तो आप जब उस कॉन्फ्रेंस में जाएंगे, बड़े बड़े लोगों को सुनेंगे, तो आपके अंदर भी इंकरेजमेंट होगा कि हम भी कुछ इस तरह का काम करें. आपका इंटरेस्ट जो है मैथमेटिक्स की तरफ और ज़्यादा बढ़ेगा. और दूसरी बात यह है कि अगर किसी अच्छे मैथमेटिशियन से 4-5 मिनट आपने बात कर लिया, तो कभी-कभी आपको बड़े-बड़े अच्छे-अच्छे आइडियाज़ मिल जाते हैं. तो ये जो कॉन्फ्रेंसेस हैं, जो सोसाइटीज़ ऑर्गेनाइज़ करती हैं, दे आर रियली वेरी इंपॉर्टेंट फॉर एवरी मैथमेटिशियन. चाहे आप हॉबी की तरह से कर रहे हों, चाहे आप प्रोफेसर हों, चाहे आप टीचर हों, मैथमेटिक्स को जानने और समझने के लिए कॉन्फ्रेंसेस का अटेंड करना बहुत आवश्यक है. तो इंडियन मैथमेटिकल सोसाइटी हैज़ बीन अरेंजिंग कॉन्फ्रेंसेस एवरी ईयर. हर साल करते हैं, अभी भी करते हैं. जैसे अभी थोड़ी देर पहले कॉन्फ्रेंस हुई थी, एनुअल कॉन्फ्रेंस हुई थी. हालांकि अब की बार ऑनलाइन हुई, ज़्यादातर तो ऑफलाइन होती है, तो तमाम लोग इकट्ठा होते हैं, सब एक जगह पर होती है. तो इंडियन मैथमेटिकल सोसाइटी इज सो पॉपुलर दैट इट ऑर्गेनाइजेज annual conferences in all parts of India. So we have been organizing annual conferences in all parts of the country, east, west, north, and south. And before independence, in the year 1921, a conference was held in Lahore, which is now in Pakistan. आप समझिए जब इंडिया डिवाइडेड नहीं था तब से ये सोसाइटी काम कर रही है. तो पाकिस्तान में लाहौर सिटी में भी कॉन्फ्रेंस की गई है. Silver Jubilee Conference was held in Allahabad in the year 1959, which was inaugurated by the first Prime Minister of India, Pandit Jawaharlal Nehru. The Golden Jubilee Conference was organized in the year 1985 at Sardar Vallabhbhai Patel University, Gujarat. The Platinum Jubilee Conference was organized in the year 2009 at Kalaslingam University, Tamil Nadu, where a postal stamp was issued by the Government of India celebrating the centenary year 2007 of the Indian Mathematical Society. और ये भी देखिए कि ऐसा नहीं है कि हम कॉन्फ्रेंसेस की सिल्वर जुबली, गोल्डन जुबली और प्लेटिनम जुबली मनाए हैं. हमारी सोसाइटी जब 25 साल की हुई तो उसकी सिल्वर जुबली भी मनाई गई, उसकी भी गोल्डन जुबली मनाई गई और उसकी भी प्लेटिनम जुबली मनाई गई. तो सिल्वर जुबली ऑफ द ईयर ऑफ द एग्जिस्टेंस ऑफ फाइमस वाज सेलिब्रेटेड इन द ईयर 1932 in Pune, where the society was started. The golden jubilee was celebrated in the year 85 in Cuttack, Odisha, and the platinum jubilee year was celebrated in Bhagalpur, Bihar, And the centenary year was again celebrated in the year 2007 at Pune. The IMS has been giving several popular prizes and awards to young mathematicians who have made remarkable contributions in their areas of research, and the number of these prizes and awards are increasing year after year. We have been organizing children meetings for the school children also. अभी आपको बताएं बड़ी इंटरेस्टिंग अब की बार जो कॉन्फ्रेंस हुई तो ये कॉन्फ्रेंस जो है वो औरंगाबाद में हुई। औरंगाबाद में एक यूनिवर्सिटी है महात्मा गांधी मिशन यूनिवर्सिटी, तो चूंकि ऑनलाइन था तो वहीं पर ऑर्गेनाइज हुई। और एक 7 साल की बच्ची को एक 7 साल का बच्चा था और उसका नाम जो है वो अ, अभिनव था। तो लोगों ने बताया कि ये लड़का बड़ा इंटेलिजेंट है, बहुत इंटेलिजेंट है। 7 ही साल का है, आप देखिए ज़रा सा एज देख लीजिए, केवल 7 साल का है। और 7वें साल में बच्चे क्या करते हैं? एडिशन, मल्टीप्लिकेशन यही सब करते हैं। एडिशन, मल्टीप्लिकेशन, गुणा, जोड़, पहाड़ा यही सब करते हैं। तो वो लड़का इतना इंटेलिजेंट है कि उसको अगर आप कहिए कि अ, 2 संख्याएँ ले लीजिए, जैसे 236 ले लीजिए और उसको कहिए कि इसको 245 से मल्टीप्लाई करो, 1 सेकंड में मल्टीप्लाई करता है वो। माने आप कैलकुलेटर में इनको फीड करके उसका आंसर जब तक निकालेंगे उसके पहले वो आंसर बता देता है। ही इज़ गिफ्टेड 3 डिजिट का किसी भी 3 डिजिट का उसका स्क्वायर, उसका क्यूब। अब 3 डिजिट का मतलब ये है कि 2 डिजिट का भी हो सकता है। डेसिमल सिस्टम में भी वो माहिर है। डेसिमल सिस्टम में 3 डिजिट का ले लीजिए, कोई 2 नंबर ले लीजिए या 3 नंबर लीजिए, सबको इकट्ठे करिए, इसको मल्टीप्लाई करके इसका आंसर बताओ। सब लोग लिख कर के ले आए थे। पहले वो चेक करके अपना लिख कर के ले आए थे कि इसको मल्टीप्लाई करेंगे तो ये होगा, इसका क्यूब ये होगा, और वो सब पूछ रहे थे, वो धड़ाधड़ बता रहा था। तो हम लोगों ने उसको क्या किया कि अपनी सोसाइटी में उसको प्लेटफ़ॉर्म दिया और कहा कि जितने लोग इकट्ठा हुए हैं, सब सवाल पूछें, वो बताएगा। और उसने बताया एंड एवरीबॉडी वाज सो हैप्पी। सो इंडियन मैथमेटिकल सोसाइटी हैज एनकरेज दैट बॉय। उसके पेरेंट्स भी थे साथ में। हम लोगों ने पेरेंट्स से कहा है कि ये तो ठीक है, ये मैथमेटिक्स तो नहीं है, मैथमेटिक्स माने केवल कैलकुलेशन है देखा जाए, लेकिन वो इतना गिफ्टेड अगर है कैलकुलेशन में तो आगे चल करके मैथमेटिक्स में भी बहुत ज़्यादा गिफ्टेड होगा। तो उसको आप एनकरेज करिए कि वो सही मैथमेटिक्स भी, जैसे आपने नाम सुना होगा शकुंतला देवी का, हाँ, वो भी एक कंप्यूटर थी। उनके अंदर भी ये खास बात थी कि आप कितनी भी डीप टाइप का कैलकुलेशन हो, पावर्स भी हो, हाँ, गुणा हो, जोड़ हो, घटाना हो, कितना भी कॉम्प्लिकेटेड एक्सप्रेशन हो, कहिए कि इसको सॉल्व करके इसका आंसर बताइए, शी विल डू इन मिनट्स, इन सेकंड्स। लेकिन वो मैथमेटिक्स लोग कहते हैं ये ठीक है, ये तो मतलब कंप्यूटर कर सकता है। तो जो कंप्यूटर कर सकता है वो शकुंतला देवी कर सकती थी। लेकिन ये है कि एक ह्यूमन बीइंग और एक कंप्यूटर, बड़ा भारी फ़र्क है। तो लेकिन मैथमेटिक्स, सही मैथमेटिक्स तो और कुछ है। सही मैथमेटिक्स क्या है अभी आप देखिएगा, हम लोग भी थोड़ा-थोड़ा बात करेंगे इसके बारे में। तो कहने का मतलब ये है कि सोसाइटी जो है दे आर वेरी इंपॉर्टेंट एंड दे हैव बीन डूइंग मॉन्यूमेंटल वर्क इन एनकरेजिंग द टैलेंट्स ऑफ द स्टूडेंट्स। जो भी टैलेंटेड लोग मिलते हैं हम लोगों को, तो हम लोग उनको इनवाइट करते हैं। जैसे रिसर्च के लेवल पर भी जिसने किया, हमने उनको इनवाइट किया कि आप एक इनवाइटेड टॉक दीजिए। उनको प्राइज़ भी दिया, उनको अवार्ड भी दिया, उनका लेक्चर कराया। तो जो बाकी मैथमेटिशियंस हैं, जैसे ही उनका लेक्चर सुना उन्होंने या उनकी रिसर्च देखा, तो बड़ा एनकरेजमेंट मिला उनको। तो वो भी उसी तरीके से अच्छी मेथड्स करने का प्रयास करते हैं। सो दिस इज़ व्हाट द सोसाइटीज़ आर डूइंग। तो हमने आपको बताया कि इंडियन मैथमेटिकल सोसाइटी क्या कर रही है, ब्रीफ में। और इसी तरीके से 2 और सोसाइटीज़ के बारे में आप इन लोगों से सुनिएगा। अब थोड़ा-सा हम स्कूल मैथमेटिक्स की बात करते हैं। अच्छा, अब ये आपके लेवल पर हम बात करेंगे। इसमें कोई बहुत बड़ी चीज़ नहीं है, लेकिन कुछ चीज़ें हैं जो आप जानते हैं, उसी को हम थोड़ा एक तरीके से आपके लिए, जैसे आपका टीचर ने आपको एक्सप्लेन किया होगा, हम रिवाइज़ कर रहे हैं। तो कुछ आइडिया थोड़ा-सा आपको देते हैं हम। जैसे फंक्शंस, आप सब लोग फंक्शंस तो जानते होंगे, राइट? मैप, नहीं, मैप मैप जानते हैं ना? एक सेट दिया हुआ है यहाँ, एक दूसरा सेट यहाँ पर दिया हुआ है, तो देयर इज़ अ मैप। यहाँ से यहाँ एक मैप होती है। मैप सुना है ना, ये तो आपके कोर्स में है। तो एक सेट ये है जहाँ से मैप चलता है, मतलब देयर इज़ अ रूल व्हिच असाइन्स एवरी एलिमेंट ऑफ दिस टू अ यूनिक एलिमेंट ऑफ दिस सेट, दैट इज़ कॉल्ड मैप। और ये सेट कुछ भी हो सकता है। इट कैन बी सेट ऑफ नंबर्स, इट कैन बी सेट ऑफ चेयर्स, इट कैन बी अ सेट ऑफ पॉलिटिशियंस, एंड दिस आल्सो कैन बी आर्बिट्रेरी सेट। तो any map which has this property that it assigns to every element of this, जिसको कि domain कहा जाता है, to an element here called range, it's called a map. Map जो है वो बहुत तरह के हो सकते हैं और sets भी, depending on sets you have lots of maps. अच्छा, यही maps जब किसी रियल लाइन के किसी एक सबसेट से रियल लाइन के किसी एक सबसेट में हो, आप रियल लाइन तो समझ रहे हैं ना? हाँ, माइनस इन्फिनिटी से लेकर के पूरी रियल लाइन, उसमें सब नंबर्स हैं, रैशनल इररेशनल सब नंबर्स हैं, ट्रांसेंडेंटल नंबर्स हैं। तो यहाँ कोई एक सबसेट ले लीजिए रियल नंबर का, और यहाँ भी कोई एक सबसेट ले लीजिए रियल नंबर का, और ऐसी मैप लीजिए जो इस सबसेट से इस सेट में हो, तो उसको फंक्शन कहा जाता है। मैप ना कह करके, क्योंकि लॉजिकल है ये पहले ऐसे ही मैप आया था, इसी तरह से मैप आया था। तो जैसे think of a map from real line to real line. We'll call it a function. Think of a map from real line to plane. So that is a function of two variables. Think of a function from real line to r cross r cross r. मतलब एक एलिमेंट यहाँ का कहाँ जाएगा, वो r क्यूब के एलिमेंट पर जाएगा, तो दिस इज अ फंक्शन ऑफ थ्री वेरिएबल्स एंड सो ऑन। ये एक्चुअली इसको कभी-कभी वेक्टर वैल्यूड फंक्शन बोलते हैं कि यहाँ डोमेन में तो एक एलिमेंट है, लेकिन रेंज जो है वो n डायमेंशनल स्पेस में जा रहा है, तो वो वेक्टर वैल्यू हो गई उसकी, तो वेक्टर वैल्यूड कहते हैं। आप ऐसे भी फंक्शन ले सकते हैं कि यहाँ प्लेन से रियल लाइन में जाए, प्लेन से रियल लाइन में जाए, तो दो वेरिएबल यहाँ हो जाएगा, ये है फंक्शन ऑफ टू वेरिएबल्स। इस तरीके से R3 से R में हो तो वो है फंक्शन ऑफ थ्री वेरिएबल्स। तो फंक्शंस आर वेरी इंपॉर्टेंट, और एक्चुअली सारी मैथमेटिक्स, चाहे रियल एनालिसिस हो, चाहे कॉम्प्लेक्स एनालिसिस हो, ये जो आप पढ़ेंगे चल करके आगे, वो सब फंक्शंस की ही स्टडी होती है। अच्छा, कुछ बड़े इंपॉर्टेंट फंक्शंस हैं जो आपको हमेशा ही डील करने पड़ेंगे, और ये जो फंक्शंस हैं, देखिए कुछ फंक्शन का हम नाम ले रहे हैं और उसमें से कुछ के उदाहरण आपको देंगे हम। जैसे पॉलिनोमियल फंक्शन, ये क्या होता है? जैसे x गोइंग टू 2x + 3, ये एक पॉलिनोमियल फंक्शन है। छोटा एग्जांपल आपको देने तब आगे चलें। जैसे f(x) = 2x + 3, दिस इज ए पॉलिनोमियल फंक्शन। f(x) = 3x² + 4x + 7, दिस इज अ पॉलिनोमियल फंक्शन। क्यों? क्योंकि x जो है उसकी जो f ले जाता है x को कहाँ? एक पॉलिनोमियल पर ले जाता है, और पॉलिनोमियल आप जानते हैं क्या होता है? जैसे 3x² + 4x + 7, इट्स अ पॉलिनोमियल ऑफ डिग्री 2। इस तरीके से f(x) = x² - 9x + 20, दिस इज अनदर पॉलिनोमियल फंक्शन। इसको आप फैक्टराइज कर सकते हैं, तो x - 4, x - 5। अच्छा, ये देखिए पॉलिनोमियल फंक्शंस क्यों बहुत इंपॉर्टेंट माने जाते हैं। इनका बड़ा इंपॉर्टेंट रोल है, और सबसे बड़ी चीज़ है कि कोई पॉलिनोमियल फंक्शन अगर है तो उसके बारे में हम सब कुछ जानते हैं। पहली बात तो यह है कि उसका अप्रॉक्सिमेटली हम ग्राफ हमेशा खींच सकते हैं, और जब किसी फंक्शन का आप ग्राफ खींच लेते हैं, तो फंक्शन ऑलमोस्ट आपके पास ही होता है। जैसे एक फंक्शन ले लें हम, पॉलिनोमियल फंक्शन डिग्री n का, तो बड़ी इंपॉर्टेंट थ्योरम है, वो ये कहती है कि इट विल हैव एट मोस्ट n zeros। A function of degree n has n zeros। तो zeros का मतलब क्या हुआ कि ऐसी वैल्यू x की जहाँ की f(x) 0 हो जाए। जैसे ये पॉलिनोमियल है x² - 9x + 20, इसको आप फैक्टराइज कर सकते हैं, तो x = 4 पर इसकी वैल्यू 0 होगी, x = 5 पर इसकी वैल्यू 0 होगी, तो 4 और 5 इसके zeros हैं, इट हैज 2 zeros। इसी तरीके से जो n डिग्री का पॉलिनोमियल होगा, इट में हैव n zeros, sometimes it may have less than n zeros, but it will have very good properties of zeros। और ये कहाँ ऊपर जा रहा है, कहाँ नीचे जा रहा है, कहाँ इसका मैक्सिमम होगा, कहाँ इसका मिनिमम होगा, all these things can be studied using calculus। और आप सब लोग calculus तो डिफरेंशियल कैलकुलस जानते ही होंगे। तो this is one kind of function, very important function called polynomial functions। अगर कोई फंक्शन आप स्टडी कर रहे हैं और किसी तरीके से आपको ये पता चल जाए कि ये फंक्शन तो polynomial फंक्शन है, तो that is a theorem। Because the moment you know that a function is a polynomial function, you have a full control on that, and therefore it's a good result। कि अभी तो फंक्शन आप सोच रहे थे पता नहीं कैसा होगा, लेकिन सडनली पता चल कि ये तो पॉलिनोमियल फंक्शन है, तो you have a beautiful result because you have a full control on that। तो one is the polynomial function। अच्छा, and the other is trigonometric functions। trigonometric functions तो आप सब लोग जानते होंगे, sin x, cosine x, sec x, cosec x, tan x, कोटेंजेंट एक्स, ये सब फंक्शन तो आप जानते हैं ना, ट्रिग्नोमेट्रिक क्या होगा तो सब जानते होंगे, इनके ग्राफ भी जानते होंगे आप। दीज आर वेरी इंपॉर्टेंट फंक्शंस। ये फंक्शंस बेसिक हैं और इनको कंबाइन करके आप तमाम अच्छे फंक्शंस बना सकते हैं, एंड दे आर ऑल नोन एज द ट्रिग्नोमेट्रिक फंक्शंस, एंड दे आर वेरी इंपॉर्टेंट because their graphs are also well known. Okay, and then you have the most important function called exponential function. You know what is an exponential function is? सुना है कि नहीं सुना है? Exponential function, for example दे सकते हैं? E to the power x, yes, very good. It's called exponential function. E to the power x के बजाय आप कोई a ले लीजिए, positive a to the power x भी सोच सकते हैं, that's also an exponential function. And this is a very important function. और सब जगह जो है नेचर में आपको मिलेगा, और पूरी फिजिक्स जो है बिना ई के चल नहीं सकती, बिना पाई के नहीं चल सकती। अच्छा देखिए, पाई जो है आप जानते हैं सब लोग नंबर, जो
नंबर पाई है, पाई की डेफिनेशन क्या है आप जानते हैं ना? कोई सर्कल ले लीजिए, तो जो सर्कल की पेरिमीटर है और जो सर्कल का डायमीटर है, इन दोनों का जो रेशियो है, ये लोग पता करते जाए कि रेशियो क्या है, ये रेशियो जो है 3 है, 2.5 है, और टाइम मेमोरियल से जब से लोग कर रहे हैं तब से ये रेशियो कोई पता नहीं कर पा रहा है कि रेशियो है क्या। तो जब नहीं पता कर पाए तो उसको कहा कि लेट्स कम दिस रेशियो इज पाई। अच्छा, पाई की वैल्यू क्या है, एग्जैक्ट वैल्यू क्या है, ये पता करते रहे लोग, इसका पूरा इतिहास है। और कुछ लोग जो है वो 2 डेसिमल प्लेसेस तक अप्रोक्सीमेशन पा गए, कुछ जो है 10 डेसिमल प्लेसेस तक पा गए, मतलब अप्रोक्सीमेट करते रहे, एग्जैक्ट वैल्यू इसकी कभी नहीं मिली। और अंत में जाकर के ये मैथमेटिक्स इंप्रूव हुआ कि इसकी एग्जैक्ट वैल्यू मिल ही नहीं सकती, डेसिमल रिप्रेजेंटेशन का फाइनाइट हो ही नहीं सकता, क्योंकि रैशनल नंबर्स का डेसिमल एक्सपेंशन अगर आप लें तो वो सम पॉइंट सम करके किसी स्टेज पर या तो बस 0 हो जाएगा या कोई डिजिट जो है रिपीट करना पड़ेगी। ये डेसिमल रिप्रेजेंटेशन की रैशनल नंबर का होगा। और ये रैशनल नंबर का ऐसा है कि डेसिमल रिप्रेजेंटेशन जो है कभी खत्म नहीं होता, ना उसका कोई पैटर्न है। तो पहली प्रॉपर्टी, पहली जो थ्योरम प्रूव हुई कि पाई जो है वही रैशनल है, बहुत बड़ी थ्योरम थी, क्योंकि बहुत लोग परेशान थे कि ब्लैक होल मिलनी चाहिए, हो सकता है 2 लाख स्टेप्स के बाद इससे ब्लैक होल मिल जाए। तो कहने का मतलब, अच्छा ये पाई हर मैथमेटिशियन के सामने पहले ही आ जाता है, क्योंकि सर्किल आपके सामने पहले ही आ जाता है। जैसे ही आप मैथमेटिक्स शुरू करते हैं, स्ट्रेट लाइन आपके पास आ जाती है और सर्किल आ जाता है, और जैसे सर्किल आ जाता है तो सर्किल का डायमीटर और फिर नेचुरली डायमीटर लेंथ अगर आपको मालूम है तो आप जानना चाहेंगे उसकी उसकी जो सर्किल है उसकी लेंथ क्या है। यही लेंथ डायमीटर, जैसे 2 इंच का सर्किल है, उसका डायमीटर 2 इंच है, तो पेरीमीटर कितने इंच होगी, बड़ा मुश्किल है। और इसीलिए पाई जो है वो तुरंत आ जाता है। अच्छा, तो आई वांट टू टेल यू दैट दीज 2 numbers, पाई एंड ई, दे आर वेरी इंपॉर्टेंट नंबर्स। लेट्स जस्ट पहले इसको देख लिया जाए। आई वांट टू टेल यू, ये जो एंगल है, एंगल आप जानते हैं ना कि जैसे इस सर्कल ले लिया और इस सर्कल को पूरे जो सर्कल है यहाँ 0 से लेकर के पूरा एक चक्कर लगाता है, तो इसको अगर 360 पार्ट्स में बांट दीजिए तो एक डिग्री का एंगल बन जाता है, और 360 डिग्री का पूरा एंगल बन जाता है, इसे ओरिजिन के नाम। जैसे 45 डिग्री, 90 डिग्री या 180 डिग्री, ये तो डिग्रीज में नापा जाता है, राइट। और दूसरा एंगल नापने का तरीका है रेडियंस। रेडियन जानते हैं ना क्या होता है रेडियन? कन्वर्जन ऑफ डिग्री इनटू रेडियन बाय रेडियन होता है। ये रेडियन से करते हैं। हाँ, यस। हम तो एंगल मेजर करने का रेडियन तरीका है या डिग्री से ना डिग्री तरीका है, लेकिन एक रेडियन हमारा कुछ ना एक रेडियन कितना होता है, कोई डायमेंशन है कि डायमेंशन का इट्स नंबर रेडियन। तो अच्छा देखिए, हम आपको जरूर बताना चाहते हैं इसको, सुनिए, जानते हैं आप लोग, फिर भी सुनिए। जैसे ये देखिए, यहाँ से ये अच्छा देखिए, ये तो हमने इसको वैसे तो कोई सर्कल आप ले सकते हैं, और कोई अगर सर्कल लें तो हाँ, कोई भी सर्कल लें, हाँ जैसे कोई भी सर्कल लें, अब ये यहाँ से लेकर के यहाँ तक ये आर्क लीजिए, आप कोई भी आर्क लीजिए, तो जैसे यहाँ से लेकर के यहाँ तक आर्क लिया, इस आर्क को इस रेडियस से डिवाइड कर दीजिए, तो ये रेडियन का एक रेडियन होगा। जो एक रेडियन होगा, अब जैसे बड़ा सिंपल ये होगा कि मान लीजिए ये यूनिट सर्कल, तो अगर यूनिट सर्कल है तो इसका रेडियस कितना हो गया, 1 हो गया। तो इसलिए अब आर्क को रेडियस से डिवाइड करने की जरूरत नहीं है, जो लेंथ आपका आर्क है वही आपका रेडियन हो जाएगा। हाँ? तो जैसे 0 से चलिए आप और ये यहाँ तक जाइए, तो अच्छा ये आप जानते हैं ना, जैसे हमने बताया आपको कि ये पूरा जो पेरीमीटर है, पूरा पेरीमीटर, ये अगर यूनिट रेडियस है तो पूरी पेरीमीटर जो है वो 2 पाई हो जाएगी। तो जो 2 पाई हो जाएगी, इसको आप कितने पार्ट्स में बांट दीजिए, जैसे 4 पार्ट में बांटिए, पाई/2, ये पार्ट पाई/2, तो यहाँ से लेकर यहाँ तक आर्क जो है पाई/2 लेंथ का हो गया, यहाँ से यहाँ तक पाई/2 का लेंथ हो गया, और यहाँ भी ये पाई/2 लेंथ का हो गया, ये चारों आर्क जो है पाई/2 लेंथ का हो गया। तो इसलिए ये जो एंगल है ये पाई/2 रेडियन का होगा, इसलिए कि जो आ, ये आर्क है और ये जो रेडियस है, इसका जो कोशेंट है वो पाई/2 हुआ। तो इसी तरीके से ये पाई/4 होगा। ये जो आर्क लेंथ है यहाँ से यहाँ तक, ये आर्क लेंथ जो है पाई/4। तो कहने का मतलब ये है कि जो एंगल है, हाँ, तो आप रेडियन में मापते हैं, तो वो रेडियन, तो एक रेडियन क्या होगा, एक रेडियन होगा 0 से लेकर के एक लेंथ का, एक लेंथ की आप आर्क ले लीजिए, वो एक रेडियन होगा। और आप जानते होंगे कि एक रेडियन जो है वो कितनी बराबर होता है, इसे पाई/4 तो 45 डिग्री का हुआ, और आगे चलिएगा तो अबाउट 57 डिग्री का ये यूनिट लेंथ जो है, यूनिट आर्क करीब 57 डिग्री के आसपास होता है, तो वो एक रेडियन हुआ। जैसे कभी कभी ऐसा कहा जाता है साइन 30 डिग्री, आप कहते हैं हाँ साइन 45 डिग्री, साइन 1, साइन 1, और साइन 1 आप नहीं बता पाएंगे, क्योंकि साइन 1 का मतलब यहाँ पर साइन 1 रेडियन, तो एक्चुअली साइन 1 का मतलब साइन 57 डिग्री, वो आपने कभी कैलकुलेट नहीं किया होगा। लेकिन अच्छा साइन होता क्या है भाई, तो ये साइन क्या होता है, जैसे ये यूनिट सर्कल का ये रेडियस है, ये सर्कल वाली यूनिट रेडियस का है। जैसे कोई पॉइंट आप ले लीजिए, तो उस पॉइंट से परपेंडिकुलर ड्रॉप कर दीजिए, तो जो परपेंडिकुलर की लेंथ है यही साइन, और जो ये हॉरिजॉन्टल लेंथ है वो साइन है। तो देखिए जैसे ही आप 0 से मूव करिए और पूरी सर्कल का एक चक्कर लगाइए, तो जैसे पहुंच जाइएगा तो यहाँ पर साइन एक्स ये होगा, और आगे जाइएगा तो साइन एक्स ये होगा, मतलब लेंथ ऑफ द हाइट ऑफ दैट पॉइंट इज साइन फंक्शन है। तो साइन फंक्शन डिफाइन हुआ, बहुत बढ़िया फंक्शन है ये, और हमने इसको कहाँ से कहाँ तक डिफाइन किया, 0 से लेकर के 2 पाई तक डिफाइन किया। क्यों, क्योंकि 0 से लेकर के पूरा 2 पाई तक का चक्कर लगाइएगा, तो जो परपेंडिकुलर है आपका वो धीरे धीरे बढ़ेगा, पाई/2 पर जाकर के सब ज्यादा हो जाएगा, फिर घटना शुरू होगा, फिर पाई पर आकर के वो 0 हो जाएगा जो परपेंडिकुलर है, फिर साइन की वैल्यू पाई पर 0 हो जाएगी, एंड सो ऑन। तो पूरी रियल लाइन को अब आप ऐसा करिए कि 0 से 2 पाई, 2 पाई से 4 पाई, 4 पाई से 6 पाई, इस तरीके से बांट दीजिए, तो 0 से 2 पाई तक एक बिहेवियर इसका होगा साइन फंक्शन का, उसके बाद पीरियडिक बिहेवियर, क्योंकि साइन फंक्शन इसलिए तो करता है। तो इसलिए साइन फंक्शन का जो ग्राफ है, तो देखिए ये साइन फंक्शन का ग्राफ है, और आप ये भी देखें कि 0 पर इसकी वैल्यू 0 है, फिर बढ़ेगी, जहाँ पर वैल्यू पाई/2 पर इसकी वैल्यू 1 हो जाती है, and then it comes to 2 पाई where again it is 0, and this is how this sine function behaves। और साइन फंक्शन मतलब ये इस तरीके से पूरी लाइन को कवर कर लेता है। तो साइन फंक्शन का जो डोमेन है वो पूरा रियल लाइन हुआ, और इसका रेंज क्या हुआ, -1 to 1, इसी के बीच में हमेशा रहेगा, ये बाउंडेड फंक्शन। और इसकी बड़ी अच्छी प्रॉपर्टीज हैं कि पीरियडिक फंक्शन, और आगे चल के आप देखोगे कि हर जगह साइन, अब जैसे सिंपल हार्मोनिक मोशन है, या जो भी तरह की चीजें होती हैं मैथमेटिक्स में, आप देखिएगा कि साइन के बिना तो काम नहीं चलेगा, तो साइन के बिना काम नहीं चलेगा, tan के बिना काम नहीं चलेगा। तो साइन एक्स फंक्शन जो है ये रियल लाइन से रियल लाइन में फंक्शन है। और आप समझिए कि किसी साइन ऑफ ए नंबर, और ये नंबर को अगर आप रेडियन तरह से देखें तो ऐसे ही इसको एक्सप्लेन कर सकते हैं। साइन ऑफ एक्स वेर एक्स इज रेडियन, इट्स ए पीरियडिक फंक्शन। इसी वजह से कोसाइन ऑफ एक्स, कोसाइन ऑफ एक्स का जो ग्राफ है वो ये क्योंकि cos 0 1 होता है, हाँ? और cos पाई बाई 2 0 होता है, cos माइनस पाई बाई 2 भी 0 होगा। तो फिर इसकी जो मैक्सिमम वैल्यू होगी वो 1 होगी, मिनिमम वैल्यू -1 होगी, और ये भी पीरियडिक होगा। इसका पीरियड ऐसे ही चलेगा। आप देखिए कहीं से भी इसका पीरियड शुरू कर सकते हैं आप। सो दिस इज द कोसाइन फंक्शन, और ये बाउंड्री फंक्शन है। एंड दीज आर नॉट द बेसिक ट्रिग्नोमेट्रिक फंक्शंस। अच्छा, और देखिए ये जो फंक्शन है ये सेक एक्स का है। इधर आप कोसेक एक्स का ले लेते हैं, ये कोसेक एक्स का फंक्शन है। अच्छा, कोसेक एक्स क्या होता है? साइन का रेसिप्रोकल, साइन का इनवर्स नहीं है। देखिए साइन फंक्शन जो है वो तो रियल लाइन से रियल लाइन फंक्शन में हो गया, और अगर उसके इनवर्स की बात करेंगे तो किसी पॉइंट पर कौन कौन से पॉइंट हैं, कौन कौन से आते हैं, वो उसका इनवर्स होगा। वो इनवर्स नहीं है। ये जो कोसेक एक्स है वो साइन एक्स का उल्टा है, इसलिए पहले 1 पॉइंट साइन एक्स। तो एक्चुअली जैसे रियल नंबर्स को मल्टीप्लाई करते हैं वैसे फंक्शंस को मल्टीप्लाई किया है। तो फंक्शंस को अगर मल्टीप्लाई करेंगे तो इन दोनों फंक्शंस का जो प्रोडक्ट है 1 होगा। जो फंक्शंस का प्रोडक्ट है वो 1 होगा। तो ये जो पहला फंक्शन है उसका दूसरा फंक्शन जो है वो इन्वर्स करना है, तो उस सेंस में या उसको रेसिप्रोकल करेंगे। तो साइन एक्स का रेसिप्रोकल उससे है, तो साइन एक्स का रेसिप्रोकल जो है वो सेक एक्स है। इसी तरीके से तो ये देखिए इसका ग्राफ, इसका ग्राफ बड़ा आसान है, क्योंकि साइन एक्स का ग्राफ लीजिएगा तो 0 से पाई में जिस तरीके से वो चलता है, ठीक हर चीज को का 1 अपान कर देना है। तो जैसे जैसे 0 के पास जाएंगे आप तो 1 अपान एक्स जो है बहुत बड़ा होगा, तो ये ऊपर इन्फिनिटी की तरफ जाएगा। तो देखिए 0 से पाई के बीच में कोसेक एक्स का जो ग्राफ है वो ये होगा। और ये क्लियरली ये भी एक तरीके से पीरियडिक है, लेकिन ये भी देखिए कोसेक एक्स जो है कुछ पॉइंट्स पर डिफाइन नहीं है। जैसे 0 पर डिफाइन नहीं है, क्योंकि साइन एक्स 0 हो जाता है 0 पर, तो 1.0 उसकी कोई वैल्यू नहीं होती। तो कुछ पॉइंट्स ऐसे हैं जहाँ की कोसेक एक्स डिफाइन नहीं है, बाकी सब जगह डिफाइंड है। लेकिन बाकी सब जगह डिफाइंड है, उसका ग्राफ किस तरह से है। ये ग्राफ अपने दिमाग में आप हमेशा रखेंगे, तो जब कभी कुछ करेंगे और जब भी आपके रिसर्च में किसी चीज में कोसेक एक्स एक्टिव होगा तो यू विल हैव आइडिया ऑफ द फंक्शन, चाहे वो साइन एक्स हो, चाहे कोसाइन एक्स हो, चाहे दो फंक्शन। So these are very important functions. Any combination of these functions is called a trigonometric function. And trigonometric functions appear in physics, in many branches of science. Suddenly they will appear, and you will feel very happy because you know the properties of all these functions. इसका मैक्सिमम कहाँ है, मिनिमम कहाँ है, ये सारी प्रॉपर्टीज बड़ी आसानी से आप पता लगा सकते हैं। So these are known as trigonometric functions. ये cos x का ग्राफ है। अगर ये ग्राफ आप याद रखेंगे है ना, तो आपको बड़ी सहूलियत होगी किसी भी एनालिसिस को करने के लिए, किसी भी प्रॉब्लम को हल करने के लिए, ये आपको बड़ा यूजफुल है। ये है सेक एक्स का ग्राफ, ये है tan x का ग्राफ। tan x क्या होता है? sin x अपॉन cosine x। तो जहां जहां कोसाइन x 0 होगा वहां ये फंक्शन डिफाइन नहीं है, वहां इन्फिनिटी होगा, तो वो सारे फंक्शन जो है छूट गए हैं। बाकी सब जगह जो है tan x डिफाइन, और tan x का ग्राफ ऐसे ही होगा। अब देखिए कि कहाँ ये माइनस इन्फिनिटी तरफ चला जाता है, कहाँ 0 होता है, और कहाँ इन्फिनिटी तरफ चला जाता है। और इसकी ये सारी ब्रांचेस पूरी पूरे माइनस इन्फिनिटी से इन्फिनिटी से लेकर के इतने ब्रांचेस हैं इसकी। और इसका जो उल्टा होगा, रेसिप्रोकल होगा, वो कोटेंजेंट होगा। इसका ग्राफ देख करके उसका ग्राफ आसानी से, तो वो भी आपको दिमाग में रखना चाहिए। ये है कोटेंजेंट का ग्राफ। So these are all very important graphs and they are all trigonometric functions. और मैं आपको इसलिए बता रहा हूँ कि इनके बारे में सब कुछ मालूम है। तो जैसे ही जब रिसर्च करते हैं तो कभी कभी किसी फंक्शन को डील कर रहे हैं, सब पता चला कि इट इज ए ट्रिग्नोमेट्रिक फंक्शन। When you feel very happy that you have a control on it, जैसे फंडामेंटल फंक्शन के बारे में ठीक इसी तरह से ये फंक्शन जो है वो एक्सपोनेंशियल फंक्शन आप सब जानते हैं एट रिकॉर्ड्स अच्छा ये एक्सपोनेंशियल कहलाता है इसीलिए कि पावर है यहाँ वेरिएबल जो है वो पावर के ऊपर है और इसके ऊपर है वो कोई पॉजिटिव क्वांटिटी है तो एक्सपोनेंशियल फंक्शन का जो ग्राफ है ये होता है जिसको आप हमेशा याद रखेंगे कभी कभी हम सोचते हैं बड़े अच्छे लोग अच्छे ब्रेन के लोगों से पूछते हैं इनके बड़े से ग्राफ जानते हैं बिगर कंफ्यूज इस में जो खास बात है जिसको आपको जानना चाहिए वो ये है एक तो ये है कि x इज 0 और जब x की नेगेटिव तरफ में चलिएगा तो ये फंक्शन घटना शुरू होता है और घटता है तो ये बड़े धीरे धीरे घटता है बहुत ही धीरे जैसे आप देखिए -1 पर इसकी हाइट देख लीजिए कितनी कम है -2 पर और कम होगी लेकिन कम ही होगी और -3 पर ऐसे चलते चले जाएंगे धीरे 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 ही घटता है लेकिन ये बढ़ता बड़ी जोरों से ये पॉलिटिशियंस भी यूज करते हैं फिर ऐसे कभी कभी कहते हैं कि कोई गलत चीज हो रही है तो वो कितनी तेजी से बढ़ रहा है जैसे मान लीजिए कहना शुरू किया कि भाई ये माइक्रॉन माइक्रॉन जो है बढ़ता है जोरों से तो कहते हैं कि एक्सपोनेंशियल तो पॉलिटिशियंस भी इस बात को तो नहीं समझते होंगे लेकिन वो समझते हैं कि बड़ी जोर से कोई चीज बढ़ती है तो उसको हम बोलते हैं कि एक्सपोनेंशियल तरीके से एक्सपोनेंशियल रेट से बढ़ती है अब आप दाहिनी तरफ देखिए कि जब आप 1 पर जाइएगा तो उसकी हाइट देखिए क्या है 2 पर जाइएगा तो हाइट से कितनी बढ़ जाती है और जरा और आगे जाइएगा तो कितनी ज्यादा बढ़ जाती है यही एक्सपोनेंशियल फंक्शंस की जो सबसे प्रॉपर्टी है वो यही है कि बड़ी जोरों से बढ़ता है बड़ी धीमे से बढ़ता है इसलिए बड़ा इंपॉर्टेंट फंक्शन है एक्सपोनेंशियल फंक्शन आप याद रखिए इसका ग्राफ जो है हमेशा याद रखिए अच्छा अब आपसे एक क्वेश्चन पूछ लेते हैं जैसे साइन एक्स का रेसिप्रोकल कोसेक एक्स का और साइन एक्स का ग्राफ देखा आपने कोसेक एक्स ग्राफ देखा आपने इसके रेसिप्रोकल का क्या ग्राफ है इसका रेसिप्रोकल होता है ग्राफ कैसे होगा x y equals to x y equals to x x ये है इसका अच्छा और ये भी देखिए कि किसी भी पॉइंट पर लीजिए आप कोई भी पॉइंट आप ले लीजिए और उस पर आप e⁻x वैल्यू ले लीजिए और log x वैल्यू ले लीजिए दोनों का प्रोडक्ट 1 होगा इसलिए कि दोनों का एक दूसरे का रेसिप्रोकल है और इस log x की प्रॉपर्टी जरा देखिए कि ये बड़े बहुत धीरे धीरे घटता है बहुत से धीरे बढ़ता है लेकिन कम होता है बड़ी जोरों से ठीक उसका उल्टा तो ये जो है एक्सपोनेंशियल का रेसिप्रोकल है और ये दोनों फंक्शंस जैसे log x हुआ अब आप थोड़ा सा और सोचना शुरू करेंगे तो जब रियल एनालिसिस वगैरह पढ़ेंगे आप आगे चल करके तो log x को देखेंगे ही log of log x देखेंगे log x देखेंगे क्यों क्योंकि क्या करते हैं ये किस तरीके से किस रेट से बढ़ते करते हैं ये बड़ा इंपॉर्टेंट
the inverse function, reciprocal on order 60. Same way.
हाँ
If you call minus x and the same nature as e to the power x, the only thing is that the axis will change. वो जो तेजी से घट रहा था तेजी से घट रहा है और ऊपर से घट
ये
रहा है log जो है वो इनवर्स
बड़ा
log फंक्शन का इनवर्स है minus x and e to the power x same function more or less same function उनके डायरेक्शन
असल में इसमें क्या है कि e to the power x जो है वो एक बाइजेक्टिव मैपिंग e to the power x जो है वो एक बाइजेक्टिव मैपिंग है कहां से कहां रियल लाइन से पॉजिटिव रियल नंबर्स में नेगेटिव नहीं होती इसकी वैल्यू to the power x और इसका जो इनवर्स होगा वो पॉजिटिव रियल नंबर से रियल नंबर वही लाभ लॉग जो है हमेशा पॉजिटिव क्वांटिटी का होगा देखिए डिफाइन करिए this is the reciprocal of that, this is the inverse of that. और ये बड़े ब्यूटीफुल फंक्शंस होते हैं इनकी प्रॉपर्टी जो है आदर्शल करके आप देखेंगे रिसर्च में ये दे आर वेरी यूजफुल every left and right step you find that these functions they are here and they are very important I thought I must tell you all these functions. I told you about the ordinal function. I told you about the trigonometric functions. I told you about the exponential functions. These are all very important functions. And as you go higher in mathematics, you will need them. So you must remember their graphs and you must also remember their important properties. Properties of read one कि किस तरीके से बढ़ता है किस तरह से घटता है e to power x अच्छा फंक्शन है कि इसको आप डिफरेंशियल करके दो फंक्शन जैसे किसी डिफरेंशियल इक्वेशन का सॉल्यूशन है कि सॉल्यूशन वही फंक्शन है इनके डेरिवेटिव अगर फॉर्म टू ऑप्शन देखिए e to power x का डेरिवेटिव क्या होता है e to power x 11 e to power x 11 e to power x log of it. So yes, some properties and these properties are important and you must know. So this is all I wanted to do because you are a student like that you should right. इसमें तो basic चीजें हैं वही I wanted you to be very level a polynomial function, a trigonometric function, and then exponential function.
Log x has algebraic, log x or exponential का algebraic which you see. Algebra दोनों का same है. Product को addition में करना पड़ता है addition को.
ये थोड़ा आजकल की चीज है इसको बोलते हैं ग्रुप होमोमॉर्फिज्म ये होमोमॉर्फिज्म की प्रॉपर्टी है आपने ये लोग जो है बेसिक मिलेगा but what I want to tell you that as you move ahead you will at every step you find these functions and you will need their properties important properties so I think this will all
Thank you, sir. For very interesting, actually, right from the introduction about the Indian Mathematical Society and to this function theory and everything. It was so interesting because we must know how we have grown up. So Indian Mathematical Society, when we are talking about the Ramanujan, we should know how these societies played role in their growth also, as well as the mathematics. And without such platforms, it is not possible to grow. It is not possible to aggregate and it is not possible to express. So these societies are basically the platform of expression, meaningful expression in a right direction as well as in a coherent way. So we must know how the societies have grown, why this National Academy is. Because you are here and through this only you are able to contact with the eminent scientists or the mathematicians. So these societies were to proliferate science, propagate science, communicate science, and finally to educate the masses, which is very much needed for the growth and for the any fundamental cultural principles in our life. So sir has very beautifully explained everything in a very interesting manner. And if you think all the disciplines of science, they are directly dependent on the mathematics itself. If you think about the biology, if Malthus was not there, perhaps Darwin was not there. Because several theories were taken on the basis of the mathematical expressions and the formulas. We need and use geometry, algebraic functions, trigonometry, topology, all these things in our biology also, without which we are not able to define the shape, size, and function of the cells and other things. Today, we have won the war of corona, almost, because many things which are very much essential regarding the mathematics are being applied to them. And only then we are able to fight it with complete and more weapons than it should in a very short time. We are very much grateful to you, sir. And sir is also completing this year his general secretary. He is associated with the academy, he is fellow of the academy, he is chief editor of the academy. So he will continue, but he has just completed one part, that is the honorary general secretary. And with this, he has contributed a lot for the development of science in general and the academy in particular. I would like to read that Professor Satyadev Sir, General Secretary Headquarters Nasi, is being felicitated for his enormous contributions to the development of science in general and the academy in particular. The academy is grateful to him for his services to the academy as the honorary general secretary from 2018 to 2020. Dr. Santosh, who is Assistant Executive Secretary in this academy. To with due regards, I would like to present the certificate also, sir. This is appreciation of our regards. Thank you, Neeraj. And we hope that in future also you will guide us in all the. Thank you. Thank you, sir.
Thank you, Professor Satyadev, for all your contributions, for all your.
So with this, I would like to request Professor UC Srivastavaji to express vote of thanks to Professor Satyadev sir. And then we will start other science mathematical sessions of the three other distinguished speakers. In between, Dr. Santosh will break for lunch for 10 minutes. The lunch packets will be served to you. After sanitation, only use them.
Thank you, Neeraj. Thank you very much. It is my proud privilege to say a few words about the great day, National Mathematical Day celebration. This time we are having both offline and online mode, and many students have come over here. I must confess and I must tell you that I am not a mathematician. I am a neurobiologist, a zoologist. But after listening to lectures, I could follow something about the mathematics and the working of the mathematics, especially when we have heard about the 10 most important, beautiful experiments in science written by Ajay Ghatak, who is the president of our academy, the National Academy of Sciences India. It was a wonderful lecture, and really I thank you, sir, very much for telling us about many beautiful experiments, and 10 you have described. That is very nice. About Professor Satyadev, General Secretary, uh, what I would like to say that I got the privilege to work with him for 4 years as a traveler also, and there are many other things also which we have done together. Now about the Ramanujan, as I have told you in the beginning, that I am not the mathematician, but when I heard about the Ramanujan and he was writing everything on the notebook and is struggling a lot because it was difficult for him to publish the papers. And after some time, people recognized him and he got the recognition. And there are many theories and many other things also about the mathematics which he has described. And that was the information for me. There are many other things also which the students were following. I may not follow that part because of not being the mathematician, but if the students are following those things, I'm very happy because this whole program is for the students and they must understand each and everything. I just thank Professor Ajay Ghatak, our president, and Professor Satyadev, General Secretary at the present moment, and Chief Editor. When I was felicitating him, he said something that you are senior because you have been the General Secretary previously. But sir, I would like to tell you one thing that I really respect mathematics as a subject because without mathematics we cannot do anything. Even if we have to do the life sciences or the zoology or the neurochemistry, neurobiology, in everything we have to use the mathematics and then some conclusion can be drawn. I thank you both once more, and as Dr. Neeraj Kumar has told that we would like to have your collaborative programs again and again over here so that the students may be benefited. And I would also like to come over here in this mathematical session so that to know about something more about the mathematics, that how the society has grown. And when you are studying about the mathematical society, I remember that there are many other societies also, including the National Academy of Sciences and Neuroscience Academy. There are many things common, but at the same time, what Professor Dev is doing, that is a wonderful job because he is publishing, he is doing some very good work also in the mathematics, and I thank him once again and again about telling us the good thing. Thank you, sir. Thank you again.
Uh, uh, Madam Paramjit Puranaji, have you joined?
Yes, Dr. Neeraj.
Thank you, madam. Thank you, madam. Thanks to see you. Actually, we are completing the inaugural function, so I would like to felicitate you, madam, also. It is our privilege. I feel pride and privilege to just express few words about you. Because both of you, Professor Satyadev sir and yourself, madam, both of you, even after several home problems or the family problems, you did so much for this academy that we are almost speechless. We are having no words to express our gratitude towards you as well as Professor Satyadev. And in the last 4 years, continuous support, continuous contributions to the development of science in general and the academy in particular, and your other contributions which made us just feel very homely with you whenever we used to meet you and other such senior members. We never felt that we are meeting with some senior officials of this academy. Always we felt that we are being guided by a guardian of ours. So it was really very much joyful, and we are very much grateful to you, madam, that we experienced such moments that we realized that we are working with not only very scholarly persons, but also the persons who are one of the best human beings. I would like to just read, madam. Uh, the National Academy of Sciences India appreciates with honor Professor Paramjit Khuranaji, General Secretary of Outer Station, Nasi, for her enormous contributions to the development of science in general and the Academy in particular. The Academy is grateful to her services to the Academy as the Honorary General Secretary from 2018 to 2021. But this is not any end. We will have your support in future also, and we'll also include, and I think you will also include ourselves in your many scientific programs and academic programs. We are very much thankful to madam, and it is another great honor that our honorable president is also with us. So
Uh, can I add one sentence, Neeraj?
yes, sir, very much. Sir.
It is such a pleasure to see you, Professor Khurana, and I would myself again like to express my deep sense of appreciation to Professor Satyadev and Professor Paramjit Khurana for their outstanding contributions. And I would like to add one more thing, that both Professor Satyadev, Professor Khurana had deep medical issues, personal problems. But whenever I would meet either of them, they would be always smiling, very warm, as if everything is normal. This is the great characteristic that both of you have, such a pleasant, warm personality. And I would like that. And I'm not talking as the president of the academy, but I'm talking just as a member of the academy. Really, my heartfelt thanks, and I feel richer in knowing both of you at a personal level. Thank you so much.
Okay.
Thank you, sir, and for being.
If I may take a minute, Dr. Neeraj.
Yes, madam. We are also
and-
just Dr. Regard. We are also sending you some Nasi gift also, madam. All your right.
Okay.
Thank you. madam.
Thank you. I would like to take this opportunity to thank the National Academy of Sciences, firstly for giving this responsibility on me, which was actually a very learning experience for me. I wanted to say this even in the annual meeting, which was held a few weeks back, but I didn't get the opportunity because we were running late. But today I do want to actually thank the entire Nasi fraternity, I would say, because I've got to learn so much with my this association with Nasi. Not that I was not associated with Nasi, but with every responsibility you get to learn more. And not only me, I think the major portion was taken over by Dr. Satyadevji because he was handling the headquarters affairs. So I think my sincere thanks to him also. I was more of a supplementary kind of a general secretary, I would say. But still, being associated with the stalwarts like Dr. Kasturi Rangan, Dr. Um, Kakodkar, Dr. Padmanabhan, and now Dr. Ghatak, I think not only that, not only the presidents, but the entire fraternity like Dr. Manju Sharma, Dr. Menon, Dr. Sharma, Dr. Kamboj, Dr. Katoj, I mean, to see them all working to see them in action, that was a biggest learning lesson for me. And to see how things are managed, how they are even under conditions. I think Dr. Manju Sharma's name is considered to be synonymous with Nasi, but I think she has been an excellent, excellent role model for all of us. Without her nurturing, her support, and everything, I think we, it's only, I think she saw that ability that maybe we could take up this responsibility, that we were able to do whatever little we've been able to contribute. But I will fail in my duty if I do not thank the Nasi staff. From Dr. Neeraj, I've learned so much how to handle the administrative matters in such a calm way. I've never ever seen him lose his cool. I think hats off to him under such stressful conditions, and I've given him so many remarks. We take the liberty of telling him कि नीरज ये काम नहीं होगा तो हम ये नहीं करेंगे. I think that's his personality which makes so much about it, and he gives us that liberty to be that free and frank with him. And yet, how he manages our inexperience and how he modulates us. I think a big thanks to you, Dr. Neeraj, for how you're handling all the affairs at Nasi, handling all the employees, all the complications, which I would say
ये वॉइस ब्रेक हो रहा है.
Yes. Thank you, madam, for your kind words.
I would like to add Professor Khurana's comment. Yeah, Neeraj, you and all your colleagues, Nasi is passing through a crisis. But you people are holding the fort with such great ability. I just do not know how to thank you all for that.
Thank you, sir. Very
तो ये लंच ब्रेक है क्या? तो हम भी लंच कर लेते हैं.
That's all. I want to also say something on this occasion. I thought that I have to give a keynote address and that's it. but Neeraj made it a sort of farewell for the two general secretaries, and I'm very happy that our term is coming to an end, and we have been trying to do as much for the academy as possible. And as Madam Khurana said, it was really a pleasure to work with great presidents like yourself, Professor Kasturi Rangan, and Kapur Prasad. And I have served the academy for 8 years, 4 years as a treasurer and 4 years as a general secretary. And it was really a pleasure to be with Madam Manju Sharma, learn a lot of things from her, and learn a lot of things from the presidents through their wide experience of running an organization, an organization like the National Academy of Sciences. We have seen many top-notch scientists giving their lectures and being recognized by the National Academy of Sciences, and strictly on the basis of their merit. The fellowship is increasing day by day, and many top-class scientists are coming, and I always feel very happy to be in their company. So I would like to thank uh, all of you for the way that you have been working together. And finally, I also wish to thank the NASI staff. Dr. Neeraj Kumar, as you all said, I think there are no words to express the way he works. I have been seeing much through the difficult days that he has been facing. And every time, whenever there is a difficult time, he always sends a poem to me. And I really enjoy that because indirectly, everything that is involved in the problem is actually nicely stated in that poem. So he has been very nice, and K.K. Srivastava, who has been handling the accounts of this academy, is a very meticulous and a very hardworking, very honest person. And similarly, the three secretaries, assistant secretaries, Dr. Santosh Shukla, Pavitra Chandan, and Singh Saab, the three secretaries, VP Singh, all the three secretaries have been very nice, and all the lower staff have been very cooperative and very nice. I always consider this as a family, Nasi family, and it is absolutely a Nasi family. And whenever there was any kind of occasion challenge to us, and we all worked together, and it was always a success. We never had to face any awkward situation, thanks to the Nasi staff. So with these few words, I want to thank Professor Ghatak, who has given so much time to this National Mathematics Day, being a physicist, but he started with Ramadan Hardy, which was really the starting point. I thank him. It was really a very beautiful lecture. I have heard him earlier also, but this was an excellent talk given by him. So with these few words, I thank all of you for the nice company today on the National Mathematics Day. Thank you very much.
Thank you, sir. Thank you, sir, for
Sorry to interrupt in between, Dr. Neeraj. My network went off. I
Yes,
could
please.
not thank everyone enough. I was just thanking you. I do want to place on record my appreciation to the other NASI staff members, the entire NASI family, especially Dr. UC Srivastava, Dr. Santosh Shukla, Dr. Pavitra Tandon, and others. And not only them, the others also. For every meeting when we've been coming, the way we've been received at the airport, led over, it was really like homecoming. And that personal touch is what we miss in other academies as well. I must place that on record. And in fact, the COVID time has really made us want to come over to Allahabad again for the same personal touch. So I think a big congratulations to the entire staff of NASI for everything they do take care of. And I'm sure NASI will do much better now, also in future also, and we look forward to better guidance with the new secretaries coming in, the new vice presidents, lots of them, and how each and every person has contributed. Thank you very much, Professor Ghatak, for organizing for this program and everything. Thank you so much.
Thank you, madam. Thank you, madam, for your kind words of appreciation. And actually, really, we all feel very pride and privileged to work with all of you. And we actually we take the guidance, and then only we do anything in the academy. But that guidance is so valuable, so precious that it makes our efforts successful. Not only successful, but it gives a flavor of grand success in all terms.
Because
तो धीरज इस अवसर पर आपका एक छोटा सा 4 लाइन का कुछ होना चाहिए.
हाँ, बिल्कुल
I
बिल्कुल
always enjoy listening to you.
हाँ, वेरी ट्रू.
सर क्या कहें कि अफसाना कुछ अलग है, क्या कहें कि अफसाना कुछ अलग है. हम तो बहुत ही कुछ करने की कोशिश करते हैं, बस पर बच जाता है फिर भी कुछ कुछ, बच जाता है फिर भी कुछ कुछ, कि पहचान हमारी कुछ औरों से भी है.
अरे वाह, अरे वाह. Thank you so much.
your lighters are not just like one
Thank you,
liner.
Neeraj.
Thank you, sir. Thank you, madam. We are now it is over to Dr. Santosh, who will take the care of other part of this program, and perhaps he will announce we'll have some break for the lunch because the lunch can happen, sir.
Okay.
Thank you very much, sir. Firstly, thank you very much, madam, and especially Professor Satya, sir, for your kind blessings. And
We are missing the lunch.
future blessings also, madam, in future also. This is not that only for the General Secretary. We are, as you said, we are the Nasi family. These titles just a title only. We hope for your kind blessings in all the future endeavors also. So, just as announced by Dr. Neeraj, sir, we have a very big on spot lunch, which is not a that we have go for the lunch and break. We are preparing for that. We have 3 lectures after this small break, and speakers are already here, as told by in annual session. First speaker is Professor H.S. Khare, sir, and then we will have also Professor Ramji sir and Professor P. Tripathi, sir. So have a just I hope you have received the packet. And in between, we are also planning going to continue the arrangement of the next lecture for the uploading the podcast etc. Then you can take start your within 5 minutes or 10 minutes we will have assemble here.
Relax.
आप लोग यही सीट पर ही लंच स्नैक्स ले लें. कहाँ पर इधर उधर जाना है?
हाँ, ले लें, बाहर में आप स्टेट के बकेट है.
Thank you, sir.
after this small lunch break. As we already announced, now our first lecture will be delivered by Dr. Precious Paris. Dr. Neeraj sir has already introduced Dr. Precious Paris, who is